Fill in the screen. Yeah. Very good morning. Welcome to 1 week FDB come workshop on secure cloud, artificial intelligence and distributed systems. Day 2. The first session, resource person, Dr. R. Ishwari ma'am. It's my privilege to introduce about the first speaker of day 2. Dr. R. Ishwari ma'am is currently working as an associate professor at NIT Tiruchirappalli, Tamil Nadu. She received her PhD from NIT Tiruchirappalli, ME in Computer Science from Anna University, Chennai, and from Bharadasan University, Tiruchirappalli. She has more than 10 years of teaching experience. She has guided 8 PhD scholars successfully, and 3 PhD scholars are ongoing. She has played different roles in organizing workshop, symposia, conferences, seminars, organizing secretary and convener. She has published 22 plus peer-reviewed SCI Scopus journals and 23 Scopus indexed conferences papers. She is a reviewer of many reputed journals, many reputed SCI journals and Scopus indexed conferences. She is a life membership in CSI, IACSIT, Soft Computing Research Society, and membership in ACM, IEEE, and IEEE Computational Intelligence Society. So welcome you, ma'am.
Thank you, Sulmarasan.
Session is over to you. Thank you.
Yes. Thank you. Today, let us going to discuss about an emerging problem. There is STEGWARE reduction against cyber attacks. So nowadays, cyber attacks are happening even in our day-to-day life. Every day we are seeing, even RBI also giving advertisement through media channels. And one of the type of cyber attack, that is STEGWARE, steganographic malware. So we are going to have a basic overview of this and the current research going on, and we are also working on that. So let us have a small overview of the working method and the future direction. Steganography, we all know what is steganography. So that is hiding information within other media such as audio, images, or text in a way that it appears to be ordinary content. So specifically, this is used to improve data confidentiality and privacy. So that's the purpose of steganography. That is hiding the presence of secret message rather than making it unreadable. But it differs from cryptography. So steganography, it is covertly writing, but cryptography is secret writing. In steganography, the information, we hide the information, but in cryptography, we transfer the information. So that is cryptography. And so the steganography totally differs from cryptography. So we can say it's a form of obfuscation, and anyone can transmit information covertly and imperceptibly. So this is the basic of steganography. But now how the attackers leverage steganography for their purpose. So first, that is the way the attackers can leverage steganography to support malicious goals. So the covert communication, data exfiltration, and malware distribution. So criminals may use steganography to communicate surreptitiously within seemingly harmless files such as images or documents. So that is, they embed sensitive information within seemingly harmless files such as images or documents, and they communicate with them. That is, they themselves can communicate without being measured by traditional security measures. So they can avoid the detection and data exfiltration. So that is, steganography can be used to exfiltrate sensitive data from a compromised system without raising suspicion, and they can hide the stolen data within the seemingly harmless files, and they can transmit to them through legitimate channels, so where they can bypass network monitoring and detection mechanisms. And the another way is malware distribution. So that is, they can embed malware payloads within legitimate files, and so which cannot be detected by normal antivirus, and which increases the chance of successful infection. Okay, come to stegware. Stegware, it is steganography based malware. That is stegware. So it is the practice of concealing data within seemingly benign content to avoid detection and bypass security measures. Here, the malware uses steganography to hide malicious data. So malware, it is a broad category of malicious software. So which consists of various threats like viruses, worms, Trojan horses, spyware, adware, and even ransomware, etc. So, so malware, especially, it is used to steal data, and it disrupts systems and damage networks, or even it can act as a spy on behalf of the attackers. And so here, stegware or stego malware, it hides codes, commands, or data within images, or even there's audio files, videos, documents, or network traffic. And it allows attackers to stealthily deliver malware and exfiltrate information, or establish covert communication channels. So once, like, without even, they can deliver the malware without the conventional security defenses such as there is antivirus software or intrusion detection system. They cannot view the delivered malware. So once the malware embedded in the cover medium, so cover medium here we call as images, audio, video, document, or network traffic. So once the malware embedded in cover medium on the victim side, so attacker can execute these malwares remotely, and they can steal information from the end user. So that is the point we have to note here. So then the malwares that malware that is hidden inside the cover medium may be in encrypted form or obfuscated form. So if the malwares are in encrypted, it is very difficult to find, and it bypasses, as we discussed, like bypasses traditional antivirus, firewalls, and sandboxes. So this is overview of stegware. So stegware, it is steganography based malware. So how the attack can happen? So this is the workflow. And attacker, they first gather target information. So that is in what way they can do the attack. So they can gather target information, they can define objectives and delivery methods, and they select a media file as a covert channel. That is what kind of cover medium they can use, and what payload they can hide inside the cover medium, and what kind of technographic technique they can use um, to uh, uh, to hide the malware. And that is the second step. So that is Stego malware creation. And third step, distributing the Stego malware. So now they can distribute the malware through emails or social media platforms or malicious websites or file sharing platforms or any compromised devices. And the fourth step is victim interaction. And once victim downloads or opens the file, and the Stego malware propagates across the network, and the whatever the instruction that is hidden inside the steganographic image, then or the cover medium, then the action will be the corresponding action will be taken, and the Stego malware attack execution. So that is it. Once it is downloaded and opened, the file is open, then it executes its operations, and then it carry out the actions such as data theft, system takeover, or it can establish a permanent connection like backdoors and rootkits. And causing escalation, there is even it can expand infection across networks, or it exfiltrate the data, disrupt operations. So this is the Stegware attack overflow. And so what are these Stegware evasion techniques? So what are the techniques they are using? That is image steganography. That is it is the embed malicious payloads within benign looking digital media, that is image, audio, video, text, and network protocols. So image steganography. So here steganography usually uses LSB embeddings, that is least significant bit embeddings. So where the least significant bit of image pixels are altered to encode malicious data without perceptible changes. So the recent malware that is which uses this embedders, that is LSB embeddings, are Duku malware and Juice or ZBot malware. So this malwares utilize this LSB embeddings to hide malicious payloads within JPEG images for covert data exfiltration. And whereas the Zeus and the ZBot malware used LSB techniques to mask command and control traffic inside image files. And frequency domain manipulation. This is another widely employed technique where data is embedded within the high frequency components of images using discrete cosine transform or discrete sine transform. The example malware is Stego loader malware, which uses this frequency domain manipulation. And the next one is audio steganography. So audio steganography is a technique. So where face coding and echo hiding, which modify the phase and frequency components of audio signals to embed hidden data. See, the possible attack is waterbug attack, which uses this technique to embed malicious code within WAV files, and it enables stealthy malware distribution while maintaining the audio files perceptual quality. That is, the audio will be looking like a normal audio, but within that some data are hidden. But it's after hiding the malware data within the audio, it looks like a normal audio, and the malware attack can happen. And video steganography. So they use motion vector manipulations. This is the sample here I've given, but many other techniques can be used. So here they conceal data within the pixel movements between frames. And text signography, they alter the text format by adding random characters and sentences or modify the existing word to conceal the malware. A good example is Platinum APT. So this is the cyber attack which utilized this text steganography to conceal all communications between server and the compromised computer. So they for that in the text at the end of the text they added some white spaces. So they add the malware within this white spaces. That is, they use these white spaces at the end of lines to hide messages, which includes the message includes the commands that are required uh, for the communication between the server and the compromised computer. So this is the recently happened attack, that is Platinum APT. And network steganography, it hides information within network traffic to avoid detection. So this can be done by modifying the headers or payloads of network packets to keep information hidden from security mechanisms. So hackers use these techniques by injecting Stego malware into the various cover mediums and network traffic for different purposes. So these are the Stegware evasion techniques. And this image steganography, so various research have been done on image steganography. So these are the image steganography methods, so using which they can hide data, benign or malicious data inside image. So several image steganography methods just I have listed, and we can use these techniques to hide data within the image. So these are the image stego malware. So you can notice, just I already mentioned, like Duku, Zeus or Zbot, and Dukes, and Signcrypt, etc. So these stego, these are the image stego malwares. And even here the techniques they have used for these stego malwares, and what they have done, that is the malfunction they have done, that is industrial infrastructure, or they specifically target banks or government defenses and etc. So that is the stego malware just I wanted to list, and which year it has come, and the format they have used for, that is the cover medium they have used for this purpose. And these are the audio and video stego malware, and for fake flash, e-skimmer, waterbug, and wave payload attack. These are the audio and stego malwares. And text stego malware, there's Platinum APT, just I mentioned, and payload web shell, Astaroth, and Madlock attack. So these are, that is audio and audio, video, and text steganography. These are the newly emerging technique the attackers using, and only very less amount of research is being carried out on this. So if you want to do research on this, so better you can do with audio, video, and text steganography. And network steganography. So here some of the network stego malwares are listed here, and the technique they have used and the target. And just I want to show what are these network stego malwares. And come to the wild malware using steganography. So these are the serious malware recently proposed using steganography. And here at Golas, it hides malicious JavaScript and image, text, and HTML files. And server, so it embeds malicious code in image files. So and the DNS changer, it uses PNG LSB, the least significant bit, to hide malware AES encryption key. So and Stego loader, Sundown. So some of the there is commonly occurred malwares are listed here. And why criminals use steganography? So the thing is evasion of security tools. There is the recently there is the currently available antivirus and firewalls. They are not capable of handling this stego malware, and that's why they are using it. And those files, they are unable to detect it as malware instead. So those files are looking like a normal file, and low detection rate. So security scans rarely inspect images for malware, and stealthy payload delivery. So the criminals, they can deliver the hidden malware. Then and another thing is, malware stays hidden until extracted and executed. That is once, because the image or the cover medium looks like a normal medium. So the malware that is hidden, even if it is detected as something is hidden, that is steg analysis. So steg analysis, it means that it checks, for example, image which consists of some hidden data, and the steg analysis, what it does, it checks whether anything hidden inside the cover medium. So that only will be checked. So even steg analysis tools are there, and many research have been done on steg analysis. So it just says that if something is hidden inside the cover medium. So if any malware is hidden inside the cover medium, then it is unable to say whether the hidden thing is malware or not. So until it is extracted and analyzed, then only it comes to know that malware is hidden. And it bypasses even email filters. That is, malicious images don't trigger standard phishing detections. And versatile attack method. So different kind of attacking method criminals can use. That is why they are using this steganography. And come to stegware case studies. So there are several real world case studies have been done. So the first one is Hovex. This is the malware targeted there is industrial control systems. So where they embed malicious payloads within image files posted on there is legitimate websites. And so here their target is that is, they extract the things, or the confident that is confident details about the control systems they try to get without triggering standard security alerts. So this is one of the earliest documented uses of steganography. And come to the recent one, that is IDAT loader deploying Remco's RAT. So this is steganography in malware loaders. So this is IDAT loader which tries to deploy Remco's RAT. Remco's, it is actually a remote control and surveillance software, that is Remco's. And RAT, it is remote access Trojan. So RAT, it is a remote access Trojan, and here they use RAT for commercial purpose. So that is RAT is sold online, and it provides purchases with a wide variety of features to remotely control computers. When a buyer buys this RAT, that is commercial RAT, they can control their systems remotely. But here what happens? So threat actors have abused this REMCO's, that is RAT, to collect sensitive information from victims and remotely control their computers to perform further malicious activity. And here IDAT loader, so this is it's an advanced loader that loads various malware families using variety of code injection and execution. And using this IDAT loader, they try to load this REMCO's RAT. That is, they try to deploy REMCO's RAT, and using which they do the attack. So this is it happened in 2024. And even another attack, it happened in the mid 2024. That is Stegano Armor by TA558. This TA558, it's a attack group, hacking group. They launched this Stegano Armor campaign, where, so this is somehow, this I have come across this, and I have some theoretical idea, that is Microsoft Office 2000 Microsoft Office 2017 has there is a drawback in this. So that is called there is memory there is corruption vulnerability in Microsoft Office 2017. So it specifically affects equation editor. So they use eqnedt 32.exe, that is equation editor. So that is a vulnerability there. So that they call as Microsoft vulnerability. And it's a remote execution vulnerability where the CVE, what CVE represents, it is common vulnerabilities and exposures database. So that is CVE. And 2017, I think they introduced a solution method. That is, they have given some patches. So that is, Microsoft released a security patch to address this vulnerability on November 2017. So that is why they named it CVE, that is Common Vulnerability and Exposures Database, that is CVE 2017. And 11882, that is code assigned by CVE. So usually they, for the attack, they assign this code. And so still, even there is whoever has this Microsoft Office without having this security patch, still the attackers use this Microsoft Office to deliver malicious documents. Even after the patch, some threat actors they have observed that still it can be exploited and to deliver malicious content. So in that, in this Stegano Armor attack, so the victims, the attackers try to send a Microsoft Office file to the victims, and tell them to, that is open the Microsoft Office. When they open it, then there will be a Visual Basic script will be downloaded from Google Drive, and in that they have hidden some image, that is JPG, and which will be stored in base64 format, and that image has some payloads, so that will be installed, and then that will try to collect sensitive data from the victim's computer. So this way, still they try to do some attack. So through this Microsoft Office, so the Office file will be looking like a legitimate file, but when a victim opens the file, then that triggers to open Visual Basic script, which will download a retrieve image, which contains base64 encoded payloads. So that will run and then collect details from the computer. So this is another case study. And a recent analysis shared by Odisek, there's a person on X in March 2025, highlights the rise of Stego malware in 2025, where they noted noted some four Stego malware attacks. So first one is W3 crypto locker, and it's a ransomware hidden in base64 encoded image. So ransomware, it's a special type of malware that encrypts victims' data and demands a ransom for its release. So ransom says it's a sum of money they demand from the victims to release the data. So they encrypt the victim's data and even the network shares and hold them for ransom. That is, they will ask some money, and then when they release the money, then they release the uh, uh, hidden data. And so this is so the here crypto locker. It's a well-known part of malware. So it specifically damage the data-driven organizations. So once the ransomware, this malware code has been executed, and as I said, it encrypts the files, and that is, they try to deliver this crypto locker through smoke loader, and then decrypts and executes the concealed ransomware, and then they will wait for the release of amount from the victim. And another one is uh, uh, Sosano backdoor. That is, they use polyglot files for obfuscation. So polyglot file. So polyglot in general, we can say like in general polyglot, say a person who can speak, read, write in multiple languages. So that is that's multilingualism. We can say like that. So polyglot in software, it means that polyglot programming, it's a practice of writing code in multiple languages to capture additional functionality that is not available in single language. So here, what they do, that is actually they say this polyglot files best friend of hackers. So a polyglot, it is a computer program or a script in more than one file format. And so in security part, say for example, when we upload image, when we apply for applications, they ask them to upload images. So they allow images only in certain formats, JPEG, GIF, kind of formats only they will allow. They will not allow other files, that is JavaScript files or PHP files. And but here the attackers try to upload files, upload a file, but that file is a combination of multiple files. So that is polyglot files. Say for example, PHAR file, that is PHP archive. They are saying it as PHP archive. So PAR file, which consists of the two formats, that is PHP format and the JPEG. So they combine those and in a single, they make it as a single file, and the file will be looking like a JPEG file. And when they upload, and the image check, that is the file format checker, will think that it is a JPEG file, but actually the JPEG file consists of both JPEG content and the PHP content. And then it tries to sit in the victim side, and then when the victim opens, then the hidden data will be triggered, and it complicates the system. And so here they try to hide the malware with this kind of form. And XFORM and Rumco's Asyncrat, so both leverage steganography for key logging, data theft, and remote control. So these techniques. So here these says the emerging need of development for detection of this kind of stego malware. And how that is, these says how attackers exploit steganography across media and network protocols, and it highlights the crucial need for the detection strategy. And even there is an initiative that is criminal use of information hiding. This initiative with Europol. They shows an increase in information hiding capable malware. So here they have given this graph that is from 2011 to 2019. So they are saying that this information hiding malware keeps increasing, and it is usually underestimated, and security experts fail to notice and categorize common approaches. So here there is the percentage of information hiding capable malware keeps increasing. And even there's a recent research by Stakansky et al. And they analyzed 106 documented cases of stego malware across 133 reports. And the study reveals that 57.5% involved as network steganography. They primarily use DNS and HTTP protocols, and 35% utilized media steganography, and 19% employed text steganography. And nearly 30% of all cases, they utilize legitimate services to mask malicious activity. So this study signals that stego malware is now a mainstream threat, and it urges defenders to find new detection techniques. So stegware detection. So stegware detection cannot be detected by usual methods, and because many of these stegware files are regarded to provide a low security risk, and are frequently ignored for further investigation. And another thing is hackers, they adopt a variety of cutting edge ways to secretly hide data, and in order to avoid detection. So there is a need for enhanced detection strategies. And the detection, when we go for stegware detection, so here these are the steps we can follow. So cover media file, so that is when stego malware file comes. So stego malware, not only stego malware, even steganographic data. So the data may be benign or malware. So when a cover media file comes, steganographic file comes, then we can do pre-processing and anomaly detection. That is, so we can extract future extraction and suspicious data detection. So that is the first step. And second, so that is, it means that first step will say whether something hidden inside the cover medium or not. So that is the first. And second one is hidden payload analysis. So now we have to analyze, we have to extract the hidden data, and then the extracted data can be analyzed whether it is malicious or a benign file. So here, this is a normal stigware detection. So the thing is like, so the first we have to analyze whether it is stigware, that anything hidden inside, and then we can extract, then analyze. So this extraction method, it's not a advised one. So that is, we can extract and then we can say like a normal, whether it is benign or malware. But the extraction is a serious one, because we extract the malicious one, and then when we execute it and then check whether it is malicious or benign, then that may harm the system. So that we can call it as a static analysis, but dynamically we need to carry out the analysis. So several malware detection tools are available. Virus Total, Malware Bazaar, Cap Sandbox, Cuckoo Sandbox, etc. So malware detection tools are available. So where we can directly upload a malware into that tool, and then it will say whether the malware is whether it's benign or malicious. So Virus Total. So virus, I think most of you know it. And when you go to the Virus Total, so there um, you can upload a PDF or document or URL. Then it will say whether the uploaded document is malicious or not. Or when you upload, even you can upload a URL. So where it will say whether any malicious contents present in the URL or not. Actually, Virus Total, it's a database of malware, and if we it's a database of malware engines. So several malware softwares are there already. Already they have executed, and then they have stored in their database. And when we upload any file into it, then it will automatically say whether it is malicious or not. Even when we upload a new malware, it will once it detects it as malware, then it will copy into its database, and then it will try to update its database. And even we have tech defense. So tech defense, where we have we can find protected malwares. So those malwares are harmless, and we can download malwares from the tech defense site. And these are the stegware detection tools. So like malware, so stegware detection tools. And here I've taken from one literature survey, this stegware detection tools from literature survey. They have listed these are the stegware detection tools. And they have listed it as, these are stegware detection tools, but actually these stegware detection tools still act as malware detection tools. And some of the tools will still act as steg analysis. So steg analysis is different from stego malware analysis. So steg analysis simply say whether anything hidden inside any cover medium, whichever, like image, audio, video, text, then it will say anything hidden. But and come to the malware analysis. Malware analysis will say whether the given file is a malicious one or a benign one. Then that is malware. But stego malware, that is something, that is malware that is hidden inside the cover medium. And now the tool has to say whether the current file, it is malicious or not. So that is stego malware analysis tool. And so here they have listed some stegware detection tools, and even other stegware detection tools, that is steg expose, zsteg, binwalk, exif tool, etc. But still these tools act as stegware stego analysis. Say for example, when we take steg expose, and they work only for specific kind of steganographic techniques. Say when we use LSB, that is when in the image, and if every least significant bit is altered, then the STEG expose can detect the hidden data. And another thing is this can detect that is detect whether anything hidden in the images or not. And even sometimes in the image, the random pixels can be altered. So that is another thing is many steganographic techniques are available. So LSB is one of the techniques. And STEG detect, this is a stegware detection tool. So it can identify steganographic content in JPEG images, and STEG-SPY detects hidden images in BMP and WAV files, etc. And they have their capability is very less. So they still act as a steganographic, there is a steg analysis. So even we tried with the Binwalker exif tool, that is we created our own malware file, and then we checked with the Binwalker, but still it has not given any signal that it is malware. And even we checked with the exif tool, and it gives the details about the file, and the file modification date, access date, and some other details, but not able to find whether it is malware or not. And even ZSTEC also we just tried, but we have not got any specific malicious detail. And available data sets. What are all the data sets available for Stego malware? So here I have taken this content from the literature survey paper, but still they have listed these are the available data sets, but we are unable to find Stego malware data set. So here, even though here it is listed, but we have not gone through all the specific data sets, but even you can note down, and then you can later on you can go through whether these data sets have Stego malware data sets, which can be useful for research. But some of the data sets just we have randomly checked, but unable to find Stego malware. So come to detection of malware in malware detection tools. So as I said, VirusTotal is one of the malware detection tools. So VirusTotal, there we uploaded some malware, and then we checked what its capability. So when we directly upload a malware file, then VirusTotal is the engines that are residing in the VirusTotal detect. Say out of 70 engines, 59 detected, and then giving the red alert, like saying that these are the uploaded file is malware. And when we detect the same stegware file, and then when we check with the VirusTotal, and the file that is bypasses all the detection engines, and the tool says that it is a benign, but actually it's a malware. So what we did, we created our own data. That is, we take one image file, and we take a malware file, and then we insert the malware file inside the image file, and then that is Stego malware. And then we try to upload the Stego malware file in the VirusTotal, and then it passes all the engines, and then malware checking engines, and then it says it is 0. And even we observed from Cybele, there's a research and intelligence lab. So they also did the same, like they created one stegware image file, and then they upload, or they insert the new variant of ransomware agent Tesla exe file into that JPEG file, and then they tested with VirusTotal, and then they observed that out of 4, there is 59 out of that 4 detect says that it is malicious. And even we checked with Google, when we try to upload a normal file in the Gmail, and we try to send, upload and send to the that we try to compose. But when we upload a normal, that is direct malware file, and it says that virus detected. But at the same time, when we try to upload a malicious, that is Stego malware file, and it says that it is benign, and then it treats that it is benign, and it tries to upload the file. So the here why we are, I saying this is the Stego malware file, it escapes antivirus softwares. So that's the case. And even when we in Windows we have Windows security, and when we try to have a direct malware file, it definitely say the threats found. But when we have a Stego malware file, then it treats that it's a normal file and the file opened. So drawbacks of stegware detection tools, they do only steg analysis, and normal files sometimes detected as malware sometimes, and even there is malwares can easily avoid detection if the hiding method is advanced. And the tools support only few formats: PNG, JPG, BMP, or VAV, and WAV, and other files still they are not supporting. And issues in detection systems. As I said, Stego analysis systems can find hidden payloads, but fail to detect whether the hidden payload is legitimate or malicious. And malware analysis, direct malware, it can take direct malware, and then it can say whether it is legitimate or not, but fail in case of hidden malware. So Stego malware analysis systems, they that is when we have Stego malware, so the existing systems cannot find hidden payload. They simply act as simply or blindly say it is a malware, and they will destroy the uploaded file. And most of the existing systems work only for image request, but even other Stego cover medium should be addressed. That is audio, video, text, and even network steganography should be addressed. And existing systems will not work for encrypted stegwares. And we did a small detection system, say binary texture analysis for malware detection. Say when we have a malware executable file, so that is converted into binary, and then bit vector to 2D array, then we convert into grayscale pattern, and then we give it to AI model, and then we check whether it is normal or malware. The same thing when we try for stegware. So malware executable, so this is the image image with malware executable. Still the image is looking like a normal image. For the same file, when we try to get the grayscale pattern, so malware grayscale pattern, that is same malware, when it is hidden inside the image, the grayscale pattern differs. So this is stegware grayscale pattern. So the same kind of analysis, that is detection method, cannot be applicable for stegware grayscale pattern. So that's why what we did, we analyze binary format of cover medium, that is, we convert cover medium to bitstream. So here this is listed. So we applied only LSB and end of file technique, steganographic technique we applied. So here stegware, that is end of at the end of file we added some malware content, and here we altered every eighth bit, and then we changed, that is we added malware content here. Then for these two cases, we just checked what we did. we collect the executable, that is binary files from the LSB bits or from the end of file, and then we put together, and then we convert into grayscale. Then it says, so the Stegware grayscale pattern and the malware grayscale pattern both are looking same. So this way we try to analyze. Here how say when we add executable file at the end of the image, so the executable file starts with the hexadecimal form, that is D94D5A. So that is the starting point we used. So LSB, every 8th bit we can directly extract the bit, but in end of file, so we use this starting hexa, and based on that we started to extract the bits at the end until the end of file. And then we convert into grayscale. Now we can see like malware grayscale pattern and Stegware grayscale pattern, they are looking same. So, but this is the simple, very simple method we applied. But from that we observe like it is concerned only with the end of file and the LSB based Stegware. And another thing is, here we extract the hidden item and then we analyzed it. But that is actually not correct. And extracting hidden items become difficult and risky when harder steganography algorithms are used. And another thing is, here this is texture dependent and it works well for specific Stegware pattern. So so here how we created the image Stegware. So here we applied only image Stegware, images from Kaggle, and benign malware samples from Malware Bazaar, where even you can download malwares from Tech Defense. So the files will be in zip form. You can unzip with the password. They commonly use the password infected, and then you can embed the malware into the normal image. Even you can use the embedding rate. So 5%, 10, 20, 30, 40, 50, likewise, like it when, because the existing, even you can check with the existing Stego malware data sets, but ensure the data set consists of malware content for research purpose. And but we have created our own data set, and then we also tried with the embedding rate. So embedding rate indicates number of pixels used in the cover medium. So if we have, say for example, when we say 5% embedding rate, it says that only 5% of pixels in the cover medium are altered. And then it is very difficult to detect whether the file is, that is steganographic file, is malware or not. It is very difficult to detect. But when many pixels are altered, then it is okay. So that also we carried. And this is the sample code, like how we just like, we have taken this is the LSB technique, LSB steganographic technique. And we have given the input image and the malware and the Stego malware in the output location, and then we try to execute. Okay, where how we can execute these Stegware files. So we can execute in Oracle virtual machines. So we have to exclusively use one separate platform for malware analysis. So it's a virtualized operating system environment. It's a controlled environment, and where you can download the malware, and then you can insert so here we have used executable files. Even other files also you can think over, like Word file, PDF, in the image, audio, video, and multiple combinations you can do. And where you can maintain a log when the file created, registry details and network connections and everything. And here the main thing is we need to analyze the behavior logs to decide if the hidden item is malware. See, here we apply the extraction method. As we extract the hidden payload and then we analyze whether the hidden payload is malware or not. That is how we see. But without extracting the hidden payload, when we upload one stego malware file, then it should say whether the image consists of malicious content or not. So that kind of detection is still going on, but that is somehow difficult. So here, importance of Oracle virtual machine for malware detection. So okay, so and stegware detection approaches, that is behavioral analysis. So watching what files do after opening, and the threat intelligence, knowing what hackers are using now, and AI-based deep steg analysis you can do, and file reconstruction and anomaly analysis. That is when the payload is hidden, we try to make it as a normal file and then compare normal file with the malware, that kind of comparison. Or you can try to make it as there is once it is detected, you try to make it as neutralization part. That is make it as a normal file, so that part also you can concentrate. So challenges in stegware detection. So what are all the things we need to consider while developing stegware detection system, irrespective of insertion algorithm or steganography algorithm? So many, for image steganography itself, we have many steganographic algorithms. So any algorithms can be used, but our detection system should detect it as malicious content inside the cover medium. And without extracting hidden items, we have to tell how it is, whether it is malware or not. And irrespective of malware pattern, so a specific pattern, it's okay. Every malware, say Trojan, spyware, adware, they have their own pattern. And when a new kind of malware comes, then our detection system should detect. And unknown and new malware, and detect wherein, okay, so detect the distributed stego. So that is payloads across multiple files. So that also should be detected. And stego malware hidden in live network traffic, and encrypted form and polymorphic form, that also we have to concentrate. So these are the challenges when we develop a stegware detection system. I think can get some idea. So these are the references I have used. Thank you. Madam, I think I was speaking, but I'm unable to hear. Unable to hear. Unable to hear. I think unmute. Unmute it. Unmute. It is in mute form. Unmute. Unmute from your side. Unmute from your side. Yes.
Okay, ma'am. The online participants can now come up with any questions if they have. Offline participants? No. Okay, thank you, ma'am. We express our heartfelt gratitude for delivering an insightful and engaging session on stegware analysis as part of our FTP. Your expert insights, deep knowledge, and clear articulation have significantly enriched the understanding of participants and added immense value to the program. We look forward to more such inspiring interactions in the future. Thank you, ma'am.
Okay. Thank you, madam. Thank you.
Now we are going for a 10 minutes tea break, and the session will resume immediately 10 minutes after. Thank you. As we continue our journey through this enriching workshop, I'd like to begin with a thought-provoking quote by Alan Kay, a famous computer scientist and visionary. The best way to predict the future is to invent it. This reminds us that in the fast evolving landscape of cybersecurity and technology, it's not enough to just anticipate changes. We must be proactive in shaping them. With that spirit in mind, we now move on to our next session, which promises to deepen our understanding and inspire innovative thinking. Let's welcome Dr. Panchami V, HOD, CSE Cybersecurity Department, IIIT Kottayam. She is the founder and faculty in charge of Cyber Labs, IIIT Kottayam. She is the coordinator of the Indian Cyber Commando Training Program funded by IFOSI MHA. Under her leadership, 5 batches of Kerala police officials were trained and funded by Kerala Cyber Operations Division. She is the principal investigator and a co-principal investigator of funded research projects. She has authored and co-authored various research publications in prestigious SCI, Scopus Index international journals, and standard conferences. She got the NASCOM Award for the Ladies Safety App and received the Best Research Paper Award in various conferences. She also received the Young Woman Researcher in Cryptography Award by the Center for Advanced Research and Design in 2022. She has professional memberships in IEEE and ACM, and editorial board member of various international journals, and the technical program committees of several IEEE conferences. Her research area includes lightweight cryptography, authentication schemes, blockchain and cryptocurrency, post-quantum cryptography, cryptanalysis using quantum algorithms, and network security. We welcome you, ma'am.
Thank you, Tomsi, for the wonderful introduction. Good morning, one and all. Am I audible to you? Yeah. Today, I am going to take the session about blockchain technology and cryptocurrency. So first, we will dive into what exactly this blockchain technology and through the wonderful application of cryptocurrency. So on one hand, we will deal with the technology called blockchain. On the other hand, we will discuss about the cryptocurrency. So this is the basic objective of today's session. Before going to the blockchain technology, this is the evolution of blockchain technology. So when we talk about the evolution, it has 4 phases, blockchain 1.0, 2.0, 3.0, and 4.0. The keywords over here, we don't discuss all these keywords, but when you deep dive into this technology, obviously you have to know about all these terms and keywords that I have put here. Okay. So, however, this is the brief about the blockchain and its evolution. When it comes to blockchain 1.0, the first phase, we call it as, yeah, so it started in 2000. 2008 to 2013. Okay, it started in this phase is started from 2018 and ended in 2013. When it comes to 2.0, it started in 2013 to 2015. 15, okay. Next is 2006. No, it's not working. Sync ആവുന്നില്ല. ഞാൻ അതിൽ തന്നെ യൂസ് ചെയ്തോളാം. Sorry. Okay. So we started with 2008 to 2013, 2013 to 2015, 2016 to 2018. So whatever happened after 18, we called as, this is the 4.0. So my point is that, so these are all the phases I put together in a single slide. So when we take care about the first phase, in 2008, what happened is that an anonymous creator called Satoshi Nakamoto, that creator introduced Bitcoin, okay, the first digital cryptocurrency. And we are all aware about this term called Bitcoin, right? So that is happened in 2008. Bitcoin was introduced through a white paper, and this white paper went viral. That is happened in 2008. In 2009, this 50 Bitcoins were introduced into the market. Bitcoin network was introduced. What is Bitcoin network? I will discuss. Okay. Bitcoin is a digital currency, right? It's a digital, we call it as cryptocurrency, that was introduced in 2009. And Bitcoin network was established, mining and all those happened in 2009. Okay. So these keywords we will explain one by one in the upcoming slides. So in a nutshell, this phase is all about money. So when we speak about crypto, at that time, people don't discuss about blockchain technology. However, the blockchain technology or the cryptocurrency, it's all about money. They know about there is a digital currency, and that's all. There is no clear distinction between the blockchain technology and the cryptocurrency. Okay. So here, this phase, it's all about money. When it comes to 2.0, there is a clear distinction happen between blockchain as a technology, and one of the application is cryptocurrency. So the distinction has happened as part of the 2.0. For example, you may heard about Ethereum, right? Ethereum. Have you heard about Ethereum? Anybody? Okay. So Ethereum is a blockchain. Okay, it's blockchain. The moment I say about blockchain, it's a network. Say we can form a network, isn't it? Here in this lab, we can form a network. It could be, we call it as LAN network, right? So similarly, we need a network so that we can share the digital currency from one party to another. So we need a network. So that network we call it as blockchains. Okay. And that distinction happened between in this phase called 2.0. So Ethereum is a blockchain, and the cryptocurrency associated with Ethereum is Ether. When it comes to Bitcoin, Bitcoin network is the blockchain, and the cryptocurrency associated with Bitcoin network is this under the same name called Bitcoin. Okay. And Polygon is yet another blockchain. Now the crypto is known as Pol. Earlier it is known as Maticoin. Okay. And most of the cryptocurrencies are built over Ethereum network. Why it's so? That we are discussing, and that happened in this second era. So second era, or the second phase, the first difference is that, or the first milestone happened is that there is a clear definition for the blockchains and the cryptocurrencies. And the second point is that if you feel that if this is an asset, you can digitize into this blockchain. Okay. So the digital representation of an asset or a product happened as part of phase 2. This is known as tokens. Have you heard about digital tokens and all? So digital tokens means gold or land or pen or whatever artifacts or paintings or any sort of items or the real world things, you can be assetized in terms of tokens. So that you have a asset with you, you are converting it into a digital representation and making it as part of the blockchain, so that when the market grows, the value of your asset also increases rather than keeping with us, right? Just like the gold, people is saying that we can invest in the gold, right? What's the market value is increasing day by day. Similarly, if you feel that something can be assetized, or if you feel that a product is with you or an asset is with you, you can make a digital representation and put as part of the blockchain, so that market value will increase. Okay. So, and this is the phase where people started investing in this Bitcoin or other blockchains. Okay. So that's the phase. The third milestone was this Bitcoin network. So now you can say that Bitcoin network is the blockchain. We need a network to transfer cryptocurrency, right? And the cryptocurrency is Bitcoin. This Bitcoin network is not developer friendly. Okay, we cannot, the developers, as we are all developers, we cannot do much in that network. So Vitalik Buterin is a scientist, and he has its own firm, and he introduced a developer-friendly blockchain called Ethereum. So that is revolutionary. When still we are using Ethereum, which is a very powerful virtual machine. Okay, that was introduced in 2013. Vitalik Buterin introduced a developer-friendly blockchain called Ethereum in 2013. In 2014, some other types of blockchain come into picture. It's called R3 Corda, right? In 2015, Hyperledger was introduced, and it's now the platform we are using for developing the private blockchains. Okay, let me clear you. There are different blockchains available, private, public, hybrid, so many are there. Here, only public blockchains are having this native cryptocurrency. Okay, so that Ethereum is a public blockchain and having a cryptocurrency called Ether, right? Bitcoin network is a blockchain and having a native cryptocurrency called Bitcoin. So none other than like hybrid blockchains or the private blockchains doesn't have its own native cryptocurrency. Okay, so only the public blockchain that we are dealing with, so that we are focusing towards the public blockchains. Okay, so these three milestones happened as part of the blockchain 2.0. In 3.0, yes, or the end of 2.0, people started using this blockchain technology for other applications. Okay, like any sort of supply chain management or some other application, so that the real users are the end users. Okay, so as an end user, they don't concern about what's the technology behind a particular application. Okay, so if we take care about a common man, he doesn't take care about like whether it's a cloud, the backend is a cloud, or it's a server, or it's a blockchain. He don't concern about that, right? So with respect to the perspective of the end user, there comes the 3.0 where they focus on the user interface. What is user interface? For example, you are using mobile apps, right? You are taking a user interface. We are interacting with the user interface, and we are entering our data, pulling the data. Backend, it could be cloud, or it could be a server, or any sort of thing, right? So we don't concern about that. So creating the backend, connecting with the blockchain, writing the rules, that happened as part of 3.0. We call this is known as decentralized applications. Okay. So just like our mobile apps, just like our web apps, decentralized applications works very well. Now we are using it. For example, you may use DigiYatra, right? It's a particular example of blockchain technology where we have a seamless, connectionless, contactless, privacy was ensured, security was ensured, and the base is the blockchain technology. So this is a very like plethora of applications were introduced in the market that we are unaware about that. The behind technology is what blockchain. Okay. So the third 3.0 is more about concentrating on end user and creating the front end, integrating with the back end is the blockchain, the network that we are speaking about, and we are creating. So whenever there is an application, it will be owned by a company, right? Company has its own rules and regulation. So they have to write some algorithms, then some conditions between this front end and the back end. So there comes the smart contract. So already the concept of smart contract was introduced in 2.0, but everything is put together as part of 3.0. So what is smart contract means? It's a very simple program. Okay. For example, I am a company owner. I can create a DR. I can create a front end for the end user. The backend will be the blockchain, and create a very small program so that this program will take the condition. I can program my company logic into the programs, and we call it a smart contract. So whatever the data we are inputting through the mobile app, it will be given to the smart contract, which is a program, and it is based on if or else condition. If this is happened, this is going to happen. Like if the condition is true, the data will be given to or stored in the blockchain. Else, it's never happening. Okay, some error message will be receiving to the end user. So this is all together put together, and we call it as the decentralized app, just like our mobile app or the web app. So I missed one thing. The smart contracts is one of the important milestones that happened in 2.0. Okay, 2.0 is very revolutionary in terms of blockchain technology. So what is smart contracts? Is very small program based on the condition. Okay, condition will works on the creator of the contract. Okay, who is the creator? It could be a company owner or any application developer. So their logic is converted into a program, and it acts as a glue between the front end and the back end, which is the blockchain. Okay. So next is 4.0. Now we are residing in the 4.0. As part of the 4.0, Ethereum 2.0 was introduced. Ethereum 2.0 was successfully implemented in the year of 2023, especially in the December. So, but there are so many phases when we successfully reach Ethereum 2.0. It way back started in 2020s. Okay. So now we are in 4.0, now industry or companies, we are all using this wonderful technology apart from cryptocurrency. So in a nutshell, my point is that blockchain is not about cryptocurrency. Blockchain is a technology. It has very beautiful applications where just like our mobile app or our web app, we can apply it in real world applications. Okay. So this is all about the introduction. These are the few applications of the blockchain technology. We more focused on the cryptocurrency. As you can see that cryptocurrency is one among the application. Apart from that, you can use for crowdfunding, banking, real estate, Internet of Things. We can connect to IoTs, supply chain like Amazon or so many supply chain management systems are using blockchain technology. It will wonderfully work on supply chains. Okay, so I just take few examples for this blockchain technology, how it works. For example, crowdfunding. Okay, so say for example, let's assume that I have a company and I want to develop a product, and for developing the product I need funds. Okay, so that normally if I need fund, some angel investors should come, right? So how I can bring investors? Either I need some wide range of contacts. Normal scenario is that I just go for some third parties. These third parties can get me the investors, so that I have to give them some amount of money, some percentage of this project amount to this third party, right? And the whole entire scenario I can replace with the simple program called smart contract or blockchain technology for this crowdfunding. How it's possible? Say, if I need the money, right? I am the developer of the product, and I can write the conditions. Say, for example, a simple condition is that if you want to be an investor, the minimum amount that you have to invest is less than, it should be equal to $10,000. Just assume that dollars or Indian rupees anyway. So a minimum amount of money should be there. So if any investor try to transfer that a particular amount less than the amount, this smart contract or the program or the application never going to accept it. Okay, this is a simple condition, right? Similarly, all the investors can see that how much amount I have used, at what phases I have used, whether I used this money for the manufacturing of the product. So I can write all these conditions in the contract. What is contract? It's a program. It's a condition-based program. Say if I do any malfunction in that, okay, so the money will be automatically revert back to the investors. Okay, it's already written. So who wrote it? I have wrote it, and I have deployed this smart contract where? In the blockchain, right? So just assume it's a network. Once I deploy it, okay, even if I am a creator, I cannot manipulate it. So that's the beauty of the blockchain technology. We call it as the immutability. And as I said, like whatever the condition I am writing, it is visible for me as well as to all the investors, right? It's known as transparency. Okay. So these are the advantages of blockchain technology when we build an application about this technology, or if we use this technology. Obviously, what's the technology? There are some properties aligned with this technology, right? These properties will be the part of our application itself. Okay, so that we can claim that our application is transparent, it is immutable, it's secure as well. Okay, so that's a way in which it works. So crowdfunding is an example. And the very beautiful thing about the smart contract is simple program, as I said, right? This program, we are all familiar about the programming language, Python or C or C++. We can create variables, right? Variables can be data. There are n number of data types like integers, strings, bytes, right? So similarly, there are data types in this smart contract so that it can store money in the smart contract. So this is not as much simple programs. These programs we say about smart contract, it can hold money. It can hold the address. The moment I say about address, you cannot connect it. But when I see the demo, I will show the demo. Either you can follow me or you can just do or install the wallets and all. In further, we will do that. Okay. So, however, the smart contracts is programs and they can capable of storing the address. Address means in this network, we are all parties, right? We have to be identified, isn't it? So this identification is done by an address. Just example, say you have account in a bank, right? So how the bank accounts are being identified? Using the bank account number is there, right? In a bank scenario. So similarly, in this blockchain technology, or when the moment we say that we connected to a network, we all are holding an address. So this crypto or this smart contract programs can hold not only the values like the int or bytes or streams, it can hold the address, it can hold money as well, isn't it? So that's the point. So this is the smart contract funding, the crowdfunding. Then just take care about the Internet of Things, like so you have a sensor module, right? Are you aware about that? So you have a microcontroller or a processor with you. The sensors will varies upon your application, and this processor will do a small kind of processing. You can write the simple code over there, put a threshold. Okay, so just assume that the sensor is a heat sensor. Okay, so you are writing in the microcontroller or the process saying that if the heat is above than this value, then actuation should happen. Actuation means the water pump should on automatically. That's the actuation part, right? And so there should be an IoT server always in this scenario, or in this setup. The IoT server will be there, because there comes the major storage as well as processing happen. So this IoT server can be replaced with the blockchain technology. So that means whatever the technology that we are using, and obviously there will be a backend for each technology. The backend, the moment we say about the backend, we can replace the backend like a server based or a cloud based with blockchains. That's the beauty. Yeah. So now we are more towards the technology. Before going to the technology, we will just discuss about the current money transaction problems that we are facing. For example, say, this is Alice, okay? And here we have the Bob. Alice want to transfer some $100 to Bob. This is the scenario, okay? And Alice is residing in India, and Bob is in some other country, maybe America or all. So does Alice can send directly, the money transfer is possible between Alice and Bob directly? One-to-one transaction is possible? No. Okay. In between Alice and Bob, there is a financial institution, we call it as bank. So that through the bank, Alice could send the amount to Bob. So obviously bank, what's the purpose of bank? Bank is providing a service, right? So for each and every service, we have to provide the service fee. We call it as the transaction fee. So nowadays, what we are facing is that if the amount is higher, a huge transaction fee has to be paid to this service providers called financial institutions or banks. So the first thing is that high transaction fee. The second thing is double spending. Double spending is the scenario in which if a party tried to spend the same money to two different parties, it is known as double spending. If I have 1,000 rupees, if I try to spend the same 1,000 rupees to Praveen and Shanaf at the same time, this is known as double spending scenario. Okay. And nowadays, the double spending may happen because of the digital errors, okay, or the very low network is there, or the range issues. So maybe because of the digital error, most commonly we are facing double spending. It's very less. The probability is very less, but still happen. Okay. For example, we claim it as the 90s or 80s kid, whatever it is. In our era, or when we are in school or colleges, major transition happened, right? When it comes to mobiles or other technologies and all, we see this one. We started from the floppy disk now to here, right? So in our scenario, first ATMs were introduced. Okay, at that time, double spending is a major problem. Okay, in India also, few cases were reported. Internationally also, there are cases reported due to double spending in ATM. For example, the scenario is that Suppose in my account there is 1,000 rupees. Okay, I proceed to one ATM, withdraw this 1,000 rupees. So there is time. At that time there is no 5G or 4G or 3G itself, right? Dial-up connections are there, isn't it? So there are few minutes it will take by the ATM machine to update its server, right? Maybe 1 second or not second, it would be 1 minute or something less than that. Okay, so what's the adversary can do is that he or she can proceed to another ATM within this buffer time, we call it as within this time, and still the bank is showing your amount is 1,000, I can withdraw. Okay, so that I can get 2,000. So it's a kind of double spending, and it's already rectified. And that's a real double spending scenario we come to experience. Okay, so next is network frauds. Network frauds, even if any technologies are there, network frauds are there, are real, and they're very smarter than those who are doing the defensive mechanism. However, based on their skill set, they can access to this central authority or bank. You can see this is a centralized approach, right? So they can access, once they got the access to the centralized database or the bank, and if they get the access, they can update the data. They can even delete few zeros in so many from the clients accounts, so that ultimately we users of that bank or the clients of those banks like lose the money, right? So it's based network frauds can play over here because of the centralized approach. There are so much and so many ways that, but I'm just focusing about the centralized approach over here. Once they get access to this this database or the server, we call it as a centralized one, the money is lost, right? Poor data recovery because of this centralized approach itself. Say, for example, in bank, nowadays we will get around 1 year or 1 year data, right? The previous transactions we get through our online banking. But if for some reasons, if you want to get the previous 10 years back data, we have to proceed to the bank and saying that, hey, we have to write a letter physically and saying that this is the reason and I need this, my transaction details from this to this. Please provide me, right? And we have to wait for days, weeks, and months to get our own data. What a hilarious thing is that we are requesting and some third party saying that we need our own data, right? Okay, so that's one example of the poor data recovery. The other example is that just think about some catastrophic things happened. Okay, so it may obviously the banks are investing huge amount of data in terms of security and protecting physically, protecting their servers, taking backups, everything is there. And if the data recovery in catastrophic things happened, of course there comes the backups come into picture, right? So at that scenario, getting our own data, right, we have to wait for months if some such situation may happen. So this is known as the money transfer problem. Obviously, a high transaction fee, double spending may happen, network frauds are there, poor data recovery because of this centralized approach. Okay, so let's see how this decentralized approach, how blockchain will resolve these money transfer problem. First is that it's all about business. So we cannot claim that there is no transaction fee. When we compare the transaction fee, it is much lower. We are claiming it is much lower. Double spending scenario never ever. There are few reports in I think it's in America. 1 or 2 reports are there in Casinovas and all. But apart from that, logically and proven that the double spending is never going to happen, because say if this is Alice and Bob, Alice, how much Alice is holding, everybody in this network can see. Okay, what are the transactions Alice has done, everybody will know. For example, now we are the network, what's my balance, you know, and what are the transactions I have done, you know. Okay, so if I if I go ahead with a double spender transaction, that means I have 100 rupees in my bank account. I transferred to Tomsi. At the same time, if I try to spend again the same 100 rupee at another person shall see, then you guys never ever accept or validate that transaction, because it's everything is transparent, right? In that way, double spending scenarios is not going to happen when it comes to a centralized approach, because decentralized approach, because of blockchain technology. Okay, network frauds, they will whatever the technology is there, they can they are very intelligent people. Okay, so based on their skill set, they will play. Okay, so what's the scenario if a network fraud is here in the network? For example, these are three peers in the network. So if someone is malicious, if someone is acting malicious, right, what he can do or she can do or the peer can do, he can update the data that he's storing with him or that peer, or he can try to update the data what others are storing, right? The moment I say about the updation, right, for example, if this is a peer who is going to act maliciously, okay, then I am storing the entire data. Okay, that I am coming to that. My point is that if I am going to act maliciously, then my own data, if I try to update it, the whole blockchain becomes invalid. Why it's so? That's one of our main objective of today's session. There are different layers for that. The simple answer is that because of hashes, but it has, as I said, that it has multiple layers. Why we are claiming that immutability is achieved when it comes to blockchain? So my point is that even if I am a malicious user, I am storing the entire data of the whole chain. I cannot, the moment I try to update the data, the chain that I am holding becomes invalid. Okay, so the chain I am holding is invalid means the chain I am storing with me is different from others. Does the others agree upon the chain? No. So it's simple like that. Okay. Then the poor data recovery, as you can see that from the figure, it is completely decentralized. Decentralized means there is a question that where this data is being stored, right? And who will validate the transaction? Where means everybody is holding everyone's data. So if we are forming a blockchain, I am storing not only my own data, I am storing the entire chain. That means your data is also stored in my chain. Okay. So it's a completely decentralized. So I don't want to go ahead and asking for others to my own data. Okay. But the beauty is that as every coin has two faces. Okay, so say I speak about Alice or Bob or me or you, right? When it comes to a blockchain network, every participant is anonymous. It's nothing like me or nothing like Alice. Okay, you don't know that this account holder is me. Okay, anonymity is being preserved. Okay. So that's the reason why this ransomware attacks and all, they're using Bitcoins or some cryptocurrencies for asking the ransoms. Okay. So they just send an account details. Account details means a random value. While getting a random value, you cannot identify who is the holder of that account. Okay, so anonymity is preserved. At the same time, decentralization is also possible. You can see my data, you can see others' data, but you cannot identify who is the person holding the account or the transactions. Okay, so anonymity is being preserved. So this is the way in which blockchain technology um, can like remove or give some justifications to the money transfer problem that currently we are facing. Yeah, with these words, I want to give you an overview that Bitcoin is a digital currency so that we can send and receive money across the world in a decentralized manner. Now you can connect the keywords, right? In a decentralized manner with minimum transaction fee. So once again, Bitcoin is a digital currency so that I can directly send to you, or you can send directly towards my account in a decentralized way. There is no central authority to verify the transactions, but with minimum transaction fee. Then there is a question that who will verify or who will validate, right? So if all over here in this network, we call it as those who are verifying, they should possess some sort of processing power, or either it depends upon the consensus algorithm that that we will discuss in further. However, there should be among us, okay, for each transaction there should be a validator. Always there will be one validators, okay, successful validators, and this money, the minimum transaction fee, right, it is given to that validator. Okay, so my point is that there is a decentralized network, and among the decentralized network, we apply some algorithm and we choose a particular person to be the validator of a transaction, and he can validate the transaction. Once he validated the transaction, the transaction fee will be given to him. This is the way in which the network works. Okay. Yeah. So then what is blockchain? This is Bitcoin, right? This is a Bitcoin definition. So if you want to transfer the amount from one person to another, there is a technology needed, right? Okay, there should be a technology, there should be a network, there should be so much and so many technology put together. We call it as the blockchain technology. So blockchain technology is the technology which enables us to transfer and send and receive digital currency across the world in a decentralized manner with minimum transaction fee. Okay, so Bitcoin is just a digital currency, and the technology which enables us to send the Bitcoin or any other digital currency, it's known as blockchain. So in a nutshell, we can say that blockchain is not Bitcoin. Blockchain is not just about cryptocurrency. It has yet another applications as well. Yeah, so this is the starting point of the explanation about the blockchain technology, where you can start with, it's a cryptographically secure open ledger. Okay, so based on the distributed ledger technology. In the next week and all, we are completely focusing on this technology for the next workshop, right? So first we will decode what is this open distributed ledger. Okay. Open distributed ledger. Say, assume that this is a network. There is only 3 persons. So here we call it as Alice, Bob, Catherine, and Daniel. Okay, already Bob is there. Okay. So Alice is holding, just assume Alice is holding some 10 Bitcoins. So this is a network having only 4 peers, and Alice is holding 10 Bitcoins. So how much Alice is holding, not only Alice, how much each party in the network is holding, it is available, it is open to everybody who is connecting to this network. That is open. Okay. So our first objective is to decode of what is open distributed ledger. Okay. If Alice tried to, so that Alice, so how much Alice is holding? Alice is holding some Bitcoin 10, right? Now, as part of the next phase, Alice want to transfer some 5 Bitcoins to Bob. Okay. So what these parties in the network will do? They will see that how much Alice is holding, whether she's capable of pay. She has enough and more money to pay this 5 Bitcoin, right? She can pay? Yes, right? If it is yes, everyone will validate, and this will be the part of the open ledger. So Alice to Bob, or now we say that the B, okay? How much? 5 Bitcoins. Okay. Now, if B is trying to transfer some 2 Bitcoins, now is it be the part of the open ledger? Ledger means what? Ledger means the transactions are stored in ledgers. Open means everything in this ledger is visible to all the parties in the network. Okay. So if B is trying to spend 2 Bitcoins, whether it will be the part of the open ledger? Yes, right? Because already B is having 5, and B can easily share, or like enough money to share 2 to C. So it will be the part of the open ledger. B to C, 2 Bitcoins. Okay. If C try to spend again 2 Bitcoins, is it a part of the open ledger? Okay. Is C try to spend 5 Bitcoins is the part of the open ledger? Does it part of the open ledger? No, because enough money is not there. Okay. So now this is the open ledger concept. Ledger means we can store the transaction. Open means it is open for everybody. That means how much I hold, what are the transactions I have done, everything is very transparent in this network. My question is that, is it distributed? Can we say that this is distributed now? No, it's not distributed now. The moment I say about distributed, it should be a copy of the entire open ledger should be stored as part of A, B, C, and D. Now we can claim that it is an open distributed ledger. So where it is storing? It is storing in the local machine, right? Local network, local machine. So this is known as open distributed ledger. So here there is a problem that how the network will maintain the same copy of the open distributed ledger among the peers. So what's the answer? Now we need a algorithm to play, right? So one thing about, you may heard about consensus algorithm, right? One thing is that we have to keep the same copies of the open distributed ledger among the peers, as well as out of these peers, we want to pick a validator to validate each transactions, right? And all this happens because of the consensus algorithm. So we apply a consensus algorithm over this network, so that that algorithm will find out a validator to validate each transactions, as well as to maintain the same copy of all the open ledgers, same among all the peers in the network. Okay. Is it clear?
Yes, ma'am. Yes, ma'am.
Here all ഇതാണോ undo undo ആ അതിലേക്ക് that's okay. ഇല്ല. Yeah, coming back to our definition, it's a cryptographically, how cryptographically secure it is, we will discuss soon. Now we have to discuss about the properties of the blockchain. Okay, when we talk about the properties of blockchain, it is secure, transparent, immutable. So that we are leading to the yet another fundamentals of blockchain technology. Blockchain technology means there is a chain of blocks. There is a chain of blocks, right? So each block, so there is a question that what data is holding by each block, right? So for the answer, for each block, we will hold transactions, hash of the previous block, nouns, and hash. So I think you know about hashes, right? Okay. Say hashes here. Blockchain means it's a chain of blocks. In each block will hold some amount of data. What are the data each block is holding? It's the hash of the previous block, transaction data, nouns, and hash. Okay. So yeah, so I will just discuss one by one with an example. Here you can see chain of blocks, right? Chain of blocks. Is there any physical chain available? No. So the concept of chain is achieved through the hashes. Okay. So what each block is holding? We have transaction data, whether we have the transaction data, hash of the previous block, it's completely mess. Transaction data, hash of the previous block, nouns. I'm just holding the lecture for 1 or 2 minutes. blockchain, it's a chain of blocks. In each block, there are few components in each block. One is the transaction data. Another is hash of the previous block. Okay. Then the hash of the block it's on. Then the nouns. Okay. So this is like in one block, we can hold multiple transactions. So how it works means in Bitcoins, the maximum size of the block is 1 MB. Okay. In Ethereum, it is increased. So the maximum size of the block, each block is having a maximum size. Okay. So that much transactions we can store. That's the way in which it works. For example, if a transaction, you can, in a transaction, you can write some comments. Okay. If you do some sort of transaction in a Google Pay or any sort, in a normal application, right, in GPS or any sort of applications, you can write something, right? You can comment something, right? Similarly, here also we can comment it. Okay. So in that way, sometimes the size of the transaction may increases. So it's not exactly like each transaction is having the same size. It may varies. So my point is that how much transaction you can hold in each block is depends upon the maximum size of the block. And it varies upon the blockchains. Ethereum is having the maximum size is different from the Bitcoins. Okay. So as the size increases, there are few advantages and disadvantages as well. As the size increases, you can hold more number of transactions. Okay. And you can see that the number of transactions that we can do per second is increasing in that way. Okay. But at the same time, the data that we are all holding the data, right? If we increase that much, the efficiency will be low because we need more storage, the efficiency, and we have to, as this is the transaction, it is connected to the market values. So a balance should be there between the creators and especially the creators of the cryptocurrencies when it comes to the maximum number of transactions that is happening over 1 minute. Okay. Of course, say for example, Ethereum 1.0, when Ethereum 1.0 started, 15 transactions per second is, they are offering 15 transactions per second. Now the Bitcoin now itself also only 15 transactions per second. Okay. Just assume, compare with a normal transaction, what we are doing in the GPace per minute. Thousands and lakhs and millions of transactions is happening all over the world, right? What about the efficiency of a normal transaction with what we are offering in the cryptocurrency? The efficiency is very low, right? So that's the reason why Ethereum 2.0 came to picture. And say when it started, the Ethereum and the Bitcoin is almost same. It's 15 transactions per second. At that time, and at another blockchain called Polygon, they are offering 25 transactions per second at that time when Ethereum 1.0 is there. So always we compare between the Polygon and Ethereum 1.0. Youngsters are very much interested in Polygon. But now we are in the Ethereum 2.0, almost Polygon and Ethereum 2.0, whatever they are offering transactions per second is similar. That means theoretically speaking, it can vary from 10,000 to 1 lakh. Practically 20 to 70,000 transactions per second is happening in Ethereum 2.0, same as Polygon. Okay. But still, Bitcoin is having 15 transactions per second. So my point is that these kinds of efficiency is connected to the maximum size, how much a block, the maximum size of the block. So the point you want to remember is that in each block, you can store multiple transactions, and how many transactions that you can hold is proportional to the maximum size of the blockchain. Okay. And so that's the transaction data. Next is this block is holding the previous hash or the hash of the previous block. As you know that this is the chain and this is the first block, we call this first block as the genesis block. And as there is no prior blocks for the genesis block, all are represented. The previous hash is represented as all zeros. Okay. So there will be not 4 zeros. It will be in Bitcoin, it will be 32 zeros. Okay. Yeah, so this is the previous. So the first block in the blockchain is known as Genesis block, and Genesis block is holding the previous hash of the Genesis block will be all zeros. Okay, then this another input is that nouns value. Nouns is a very random number. It's a very it's an integer value. It's a random number. Once we use a particular number, we don't reuse it. So it plays a very important role when it comes to blockchain technology. So we said that all the blocks are unique, right? And the main reason because of that is this nouns value. Okay. So as then timestamp is also there, when the time, date, where the block is being created. So all these things we are giving to a hash function, all these values given to a hash function, so that this hash is generated. And this hash is also been the part of this block. So in that way, we can say that each block consists of the previous hash, nouns value, timestamp, date and time, as well as the hash of that block. Okay. So here hash is used to uniquely identify each block. Each block, in order to uniquely identify each block in blockchain, there are two ways. One is the block. You can see the block number. Can you see the block number? As well as the block hashes. Through the block hashes, you can uniquely identify blocks in the blockchain. Okay, just like your roll number and your register number, right? There are so many classes over here, and the roll number in our institute, it's something different, but still what we have faced is that we have a roll number for a particular class and a register number. In university wise, we have a register number, right? So if you want to uniquely identify, obviously the unique identifier will be our register number. So in that way it works. So we have a block number as well as the block hash is there to uniquely identify each blocks in the blockchain. Okay. So similarly, there are multiple blockchains. Each blockchain has its own blocks and its own transactions. And how the first point I want to emphasize over here is that how immutability is being maintained here, right? If we try to tamper this data, what will change? Say this is a malicious user. Okay, just assume that. So he tried to tamper his own data. Okay, that means he's storing not only his data, everybody's data he's storing. So he can easily tamper it, right? So once he tamper, what happens? The block hash that he's holding, or the blockchain, the point is that not a single block he's holding the entire blockchain. So the moment he tamper any blocks in the chain, it will not only affect a single block, the entire blockchain so the entire blocks after this block, it will be changed. Okay, so if anybody do this updation or manipulations or some modifications, the entire chain becomes invalid. Okay, this is the one reason we are saying that immutability is achieved. The second reason is that as you know that we are in the era of high performance computers, quantum computers. So we can do parallel computing and all, right? So so the point is that it's all about coming up with a valid hash. So that's the point. We have to if we come up with a valid hash, even if we have manipulated. Okay. So how we can bring the valid hash? With the help of some parallel computers or very large high performance computers, we can bring it up, right? Isn't it? So even if that, there comes the consensus algorithm works. Okay. So the first point of immutability is that hashes. The second point is that if large performance computers are there, still immutability should be preserved, right? How? Because that's the significance of the consensus algorithm. In Bitcoin, we are using proof of work consensus algorithm. You may heard about the term called mining and all, right? Mining, right? So consensus in proof of work consensus algorithm, we are coming to that. I will just give an overview. In proof of work consensus algorithm, it of course it will find a validator. Okay, so validator in the sense, say if a block is newly generated, right, using the proof of work consensus algorithm, we are validating this transaction inside the block as well as this block will be the part of the chain. So there are multiple things happening. Consensus algorithm, we apply a consensus algorithm to this network. Upon applying the consensus algorithm, we find a validator. This validator can validate all the transactions in the blockchain. Once the block is validated, this block will be the part of the chain. There are 3 steps is happening. Okay. So this is all because of the consensus algorithm, and this should happen within 10 minutes. Okay, this should happen within 10 minutes. Okay, so my point is that if you have a very large performance computers, okay, even if you have a very large performance computers, you can bring a valid hash of a single block within 10 minutes. That is possible. But can you bring a valid hash for all the blocks in a blockchain within 10 minutes? No, it is infeasible, right? That's the second reason why we are saying that it is immutability is being achieved. My point is, say, if you want to validate, I'm an attacker. I just attack a particular block. As a result, the entire blockchain becomes invalid. So what I should do, I have to go to each block, make it valid, right? So valid means I have to bring up a valid hash. So in order to bring a valid hash for one block, it takes 10 minutes. Okay. So my point is that it is infeasible to find a valid hash for all the blocks in a blockchain within 10 minutes. It is infeasible. Okay. Within 10 minutes, we cannot find a valid hash for all the blocks in the blockchain. We can find, or we may find, with respect to one block. It could be possible because of high performance computers or quantum, whatever it is we have. But it is infeasible. Infeasible means what? It is the probability is very less to find the valid hash of all the blocks in the blockchain within this 10 minutes. So the 10 minutes time frame is very crucial. So just example, OTP, how OTP works? So only eight characters, right? Or maybe more than 5 characters. Okay. So we can assume, right? We can just do some brute force, or we can just assume and come up with the OTP. How it works? Within that time frame, it is valid for how many seconds or minute? It is the 1 minute, right? It is valid for 1 minute. So within the 1 minute, making all the possible combination of an OTP is infeasible. Apart from that, the try we can apply over here is only 3. So there are so many constraints to overcome, or for a malicious thinker or a hacker or a cracker to crack this OTP, right? So it is infeasible to bring a valid solution within the time frame. So the time frame matters a lot. Similarly, even if you have a whatever the high performance computers you have, within 10 minutes, producing the valid hash for all the blocks in the blockchain is infeasible. So that's the second reason. Third reason is because of the 51% rule. That means, say, this is a network. Just assume in this room we are a network, right? Say I am an attacker. I changed the I done my some sort of updates. Then I have so much and so many computing power is that, and just assume that I bring the valid solutions for all the hashes within the 10 minutes. Just assume that. Okay. Then do you agree to my new chain? You all guys are holding the same chain and it's completely different from what I am holding. Do you accept my chain? Until and unless 51% of the peers in the network accept it, yeah, it becomes valid. Because in Bitcoin or in any blockchains, okay, so there are millions and billions of nodes, right? Can I influence this 51% of that millions network to accept my chain? No. Is it feasible? No. So that's a third reason why we are saying that immutability can be achieved in blockchain. Is it clear? It's already one, right? I will just nutshell. ലിങ്ക് എടുക്കണമായിരുന്നു. ഇതിലുള്ള കളികൾ. Yeah, so this is, can you know? Yeah. So this is the hash SHA-256 algorithm is used in the Bitcoin network. For example, I'm just entering few data. Here hash is used to uniquely represent your data at this premise, but there are different applications over time in blockchain. So hashes, there are so many properties, right? So you can see that the one property is that for the varying data, it always give you a fixed sized hash, right? And so this hash will act as a unique identifier for your message. So that property, we are applying it in the blockchain, but there are so much and so many applications of hashes we apply, we use in blockchain. One among is the unique identity of the hashes. So for your message, this is your unique identifier. Okay. So if you try to change any value over here, you can see that it is changing, right? So that's the hash. Now comes to blockchain. You can see that there is a block number, a nouns value is there, right? Here there is no data, and a hash of a block is there. Okay, so my question is that can you identify any difference with a normal hash and a block hash? Can you identify any difference? Yeah, some zeros are in front of this hashes, right? And it is directly proportional to the time taken to find the block hash. So that means you may come across through the consensus algorithm called proof of work. Okay, proof of work. In proof of work, what we have to find is that, so what the consensus algorithm will do, they will find a validator, right? The consensus algorithm will pick a validator. So this will act as like a cryptographic puzzle. So we are all peers, right? Among the peers, not all the peers in the Bitcoin network can be the validators. So those who are having enough and more computing power, right? Those can be the validator. That's a one those who want to be a validator in the Bitcoin, you need enough and more computing power with you. Okay. But it is something different when we come to Ethereum. Ethereum, we are using proof of stake. Proof of stake in the sense, how much stake you hold, how much Bitcoin or how much Ethereum you hold, that much you can, that much probability is there you be the part of a validator. Okay. And the concept may varies based on different blockchains and different consensus algorithm. So when it comes to Bitcoin, the consensus algorithm, we are using the proof of work. Proof of work means the first criteria to become a validator in the Bitcoin is that you need enough and more computing power with you. Okay. So why we need this much power, right? It's not environmental friendly because we have to say the validate. If I want to become a validator among this network, I want to hold some computing power with me, as well as I want to succeed a cryptographic puzzle. The puzzle is that I have to input the transaction data, nouns, first nouns, and there is a target hash value will be there. The network will say to me that, hey, there is a target value, say called X. So just assume this is the target value. Okay. Target value always consists of some few zeros, 4 zeros. That's my target. So I have to come up with a block hash which always having 4 zeros. But these values can change. Okay. So the concept is that whatever the hash I am developing should be less than or equal to the target value. So who will fix the target value? The network. You guys can fix the target value, or the network can fix. We cannot contribute that. There is an algorithm to fix the target value. And so there is a target value for each validators, or we call it as miners. So we want to find a hash value which is less than or equal to the target value. How we can find the hash value? We have to input the transaction data. We have to put especially nouns. So we will try for one nouns, because the rest another thing is not like it is fixed, right? Transaction data. We have to try for one nouns. Then we compare whether the hash we produce is equal to or less than or equal to the target value. If yes, we will get the money, as well as we can validate the transaction. So this is known as the mining. So the moment we say about mining, this is actually happening. Okay. And those who are doing mining, we call it as miners. So what the miners will do? Miners will want to find out a particular block hash, and that has to be less than or equal to the target hash, which is proposed by the network. Once it's there, we got around 3.125 Bitcoins. It's around 1 crore or something like that, near to 1 crore, as well as we can validate the blockchain. Okay. So basically, in order to become a miner, we need enough and more computing power. Then we have to complete a cryptographic puzzle. Once we succeed the cryptographic puzzle, we can become a validator. So this is happening. This is actually happening in the proof of work consensus algorithm. Okay. So my point is that if I try to update it, just a simulation, what happens? This becomes the invalid one, right? How you can identify it's an invalid one? We just set the hash. It's a normal hash, right? Now we want to make this as a valid block. So how we can make the valid block? We have to do the mining. So mining means we have to input, we take a nouns, one particular nouns, transaction details to the hash value, and we will get a hash code. This hash code will be compared to the target hash. If the condition is true, we can say that we come up with a valid block hash. So this process is known as what? Mining. And those who are doing this process is called miners. Now this is the blockchain. So now we started with the hashes, then blocks, then blockchain. What about the blockchain? Here we have multiple blocks, and you can see that for the block 2, the previous hash of the block 2 is the hash of the block 1, isn't it? So similarly, the consecutive blocks is also following the same strategy. If I'm just tampering any of the blocks in the blockchain, what happens? Not only that particular block, the entire chain becomes invalid, right? So one reason the immutability is that because of hashes. If the blockchain that I am holding, if I'm acting as malicious, that affects myself, right? The whole chain becomes invalid. Just assume that that's a reason. Just assume that if I have enough and more computing power with me, and in order to find a proper hash, so I want to find the proper hash of how many blocks? These much blocks, right? In order to find a proper hash of a single block, how many minutes it may take? 10 minutes. So this 10 minutes plays a crucial role in the cryptocurrency. Anywhere you are residing in the world, if you transfer a cryptocurrency from one person to another, especially in the Bitcoin, on an average case scenario, within 10 minutes, you will receive the Bitcoin. So that 10 minutes, right, that is directly proportional to the consensus algorithm, which is proof of work. So I speak about a crypto puzzle, right? So there are few properties of crypto puzzle. Okay. This is like, it is not too difficult and not too easy. An average difficulty should be there in such a way that the solution for that, what is this solution? We want to find a particular hash which is less than or equal to the target hash, right? And what we have to input, we have to make a trial and error based on the nouns value. We put first nouns not working, second nouns not working, third, and so in a statistical way we can say that we have to, within 10 minutes on an average, 10.5 quadrillion nouns we have to make it like brute force play. Trial and error method, through the trial and error method, on an average case scenario, 10.5 quadrillion. So applying the 10.5 trillion quadrillion attempts, like, does it can happen with a normal system? No. Yeah. So my point is that 10-minute plays an important role in which, for validating a single block itself may take 10 minutes. So is it feasible, or is it possible to find out a valid block for all the blocks in the blockchain within 10 minutes? No, that's the second reason. And that's the second reason, because of the consensus algorithm, we are saying that immutability is there. So this alone take 10 minutes. So the attacker want to do the mining of all the blocks. If the attacker successfully can do the mining of all the blocks within the 10 minutes, then he success. So that is infeasible. Okay. Where whatever the computing power you come up with, so that much support is not there. Okay. So that's the second layer. We normally we don't speak about the second layer of immutability. And the third layer is all about the distributed concept, where even if I applying all the computing power, I come up with a new blockchain, right? New blockchain, then yeah, so then the others won't accept it. Okay, so because of the third reason is the distributive nature. Even if we come up with a newly updated valid block, which is entirely different from the block that the peers in the network are holding, so none of them will accept the newly formed block. There is an attack called 51% rule, or it's a rule actually, but the attack is also may happen when it comes to a smaller network. This attack, 51% attack, is very prevalent. But when it comes to a larger network like Bitcoins or Ethereums, it's not going to happen because we cannot, as an attacker cannot influence 51% of the peers among the billions and millions of in the network. So in that way, if 51% agrees upon a newly formed chain, then it is acceptable. Then that is known as 51% attack. Okay, so that means I can influence in this particular network, in this particular class, if we form a network, if I could influence 51% of you and saying that, hey guys, you want to accept my newly formed chain. If you accept it, then it is an attack. Okay. So, but it is not practically infeasible. And that's the reason why we are saying that immutability is achieved in blockchain. I think that's all. Security, I am just venting about the cryptographically, how cryptographically secure. One is hashes, another because of the digital signature, but we don't have the time. So this is an overall view of the blockchain technology. If you have any queries, please ask.
Online participants, you can unmute and ask if you have any queries. So we extend our sincere thanks to Dr. Panjami ma'am for delivering an enlightening session on blockchain technology and cryptocurrencies as part of our FDP. Your expert explanations and valuable insights have greatly enhanced the participants' understanding of these transformative technologies. We truly appreciate your time and effort in making the session engaging and informative. Thank you, ma'am.
Thank you, coordinators, for giving me the opportunity to deliver a session. Thank you all, and for patient listening.
We'll be resuming the session at 2 p.m. Let's refocus and gear up for another insightful discussion that promises to add great value to our learning. Without further delay, let's welcome Dr. Venkateshwaran S. He's currently working as Assistant Professor, Department of CSE at IIIT Kottayam. He completed his PhD from NIT Trichy. He's also the recipient of the prestigious PhD Research Fellowship from MIT under the Vishweshwara PhD Fellowship Scheme. He completed his ME in Software Engineering from the College of Engineering, Guindy, and his BTech in CSE from Annamalai University. He has worked as an assistant professor, senior grade at VIT Vellore, and assistant professor at NIT Puducherry. His expertise lies in several advanced domains, including distributed computing, big data analytics, cloud computing, HPC, advanced database systems, ML, and DL. He has published several papers in reputed journals and conferences in the field of big data and distributed computing. Over to you, sir.
Thank you, ma'am. Thank you for the brief introduction about myself. And I would also like to thank the organizing team for giving this opportunity to take a session for you. And I want to confirm that online participants, hope you are able to see my screen and my voice is also clear, right? Online participants, can you able to confirm?
Yes, sir.
Okay.
Yes, sir. Yes.
Thank you. Okay. So the today's session, we are going to discuss about the topic, designing and deploying a fault-tolerant cloud storage architecture, theory to practice. Okay. Since this set of students are not having a basic understanding about the cloud, so what I plan for this today's session is I'm going to start with the cloud fundamentals. Okay. What is cloud computing? And then we are going to take some of the cloud service providers. You can able to take AWS or Azure, whatever it may be. Okay. So I'm going to take the AWS cloud, and we are going to discuss about the global infrastructure, what AWS is having. After that, we are going to discuss about our core and fundamental concepts of today's session. That is the cloud storage. In the cloud storage, we are going to start with what is Amazon S3, and we are going to discuss about the key components of cloud storage like buckets, objects, and how the cloud storage works, and what is the consistency model they are using in order to store the data which is in the Amazon S3 that we are going to discuss. Okay. After that, I try to show you a demonstration. Okay, how to create a bucket and how to upload an object inside that bucket in Amazon S3. Okay, if you are having a cloud account, you can able to follow the same material what I am doing. Okay, so that you can also get familiar. Okay, otherwise you can able to have the recording sessions, you can able to refer and you can able to do the same, right? After the cloud storage demo, I'm going to take the access control, because the access control and bucket policy is some way related to your workshop theme, right? Cloud security. So I'm going to take, I'm not more comfortable in the security concepts, but I'm going to take you some basic concepts related to cloud security like access control and bucket policy. For that, I'm going to create two demonstrations. The first demonstration is creating a bucket and make the objects which is publicly available using ACL. ACL is access control list we are going to discuss. After that, I'm going to define some kind of a bucket policy. Okay. In the bucket policy, I'm going to tell that who are all the persons who can able to access my object, what kind of actions they can able to do it, whether they can able to read my data or write my data, delete my data. Those things we are going to define in the bucket policy. And based upon that, we are making the people to read some specific objects, deny some specific request likewise, right? So let us move to the cloud fundamentals. So what is cloud computing? Anyone? Yes? Great. Any other answers? What is cloud computing? High accessibility, what he has mentioned. You can able to access the data anywhere from any location at any volume of data, right? And any other key highlights of using a cloud computing paradigm? Just to try to make it as a more interactive. It's not, it's a formal discussion forum, right? Yes, please. Okay, we can able to deploy some kind of host, some kind of applications in the cloud, and we can able to make it as publicly available so that the other users can use that particular application, right? Great. Anything? Storing the data in the centralized store. Okay. Yes, it's a good answers what you have given. So online participants, if you want to interact, you please interact. Okay. Okay. So I'm giving a definition of a cloud computing. Hope my screen is visible, right? Yeah. So cloud computing is on-demand delivery of resources. The resources may be in the form of a computing resources, or it may be a storage resources, okay, database, applications, or IT resources, anything, okay. Cloud computing is a on-demand delivery of resources, okay, through some kind of a cloud service providers. We know that cloud service providers, right? We know that Amazon AWS, Microsoft Azure, Google is having GCP, and Alibaba Cloud. So what is cloud computing is? It is the demand of delivery of the resources via some kind of a service providers via internet using pay-as-you-go pricing model. Pay-as-you-go pricing model in the sense how much amount of resources you are using, that much only you will be charged. Once you are completing your task, you are shutting down your machine in the sense you will not be charged after that, right? So that is what we say. Pay-as-you-go pricing model. Okay. In the lighter terms, we can able to tell that the cloud computing is renting someone else's computer. Okay. Suppose I have some kind of a task to be done. I'm not having a resources in my hand. Okay. What I can do is I can deploy a machine from Amazon AWS or Microsoft Azure, whatever the service providers, within 1 or 2 minutes, and I can able to use that resources Okay, and I can able to perform my computations, right? That is what we say, renting someone else computers. Okay, so what kind of major services will be provided? Resources will be provided in the sense we can get the resources in the form of a compute, storage, networking, and databases, right? So what are the advantage of using cloud computing? Just 1 minute. Okay, sorry for the interruption. Okay, what are the advantage of using cloud computing? The first advantage compared to your on-premise environment or your own machine, if you are using a cloud computing, the first advantage is trade capital expenses for variable expenses. That is, you need not to invest heavily on the infrastructure, right? If I need some kind of a task to be done, what do you do? For example, I have my research problem that needs to be computed. So what you do, you establish some kind of infrastructure, right? You buy some kind of a computer, hardware, machine, servers, and everything, and then you are working on it, right? So some kind of a invest heavy infrastructure is required. So when you are using a cloud computing, you need not request some kind of a investing on the initial infrastructure. You can directly deploy the machine within a minute, right? And also you can pay for only the amount of data they are using. You can pay for only the amount of resources you are using, right? And next one is benefits from economies of scale. Benefits from economies of scale in the sense you cannot able to compare the facilities available with Amazon and Microsoft, right? They are having a very huge infrastructure. They are having a well sophisticated hardware architectures, right? That architectures you cannot able to buy and buy in the local shops. Okay, they are having 100 GB GPU. That architecture, even in India, it is not available. You have to go and US and you have to procure this document, right? So benefits from the economies of scale. And next one is a stop guessing about the capacity. This is the most important thing when you are moving on to the cloud computing. So what is this? Stop guessing about the capacity. Yes. So it is highly scalable. Okay. For example, you have some kind of a problem. Okay. You are building some kind of application. Okay. Some booking software or any application you are building. So what you are going to do is you are going to host that application in some server, right? So if you are going with some kind of a on-premise environment, or if you are going with some kind of a local machine in the sense, okay, you need to make an assumption that how much people will use that particular applications, right? Based upon that, you need to deploy it in the appropriate resources, right? Suppose you expect that that application will used by millions of users. So you procure lot of high hardware architectures, high infrastructures, but it is not used by that many people. So what happens? You are wasting your money, right? And also in another case, you feel that the application will not be used by many people. So you have built a small server, you procure some small server and you host it on the application. Suddenly the application gets picked up and it has been used by millions of users all over the world. So what happened at the time? You will face some kind of a downtime, right? Even you think about IRCTC during Takkal time, right? Why you are facing too much difficulty during the Takkal time? Because many number of users are accessing that particular application. It cannot able to withstand with respect to the growing demand of the data. Okay, but if you are having a cloud computing environment, okay, you need not to guess about the capacity. You have a auto scaler features. You can able to, if you are enabling the auto scaling in the cloud, what happens is based upon the growing data, your resources will get scaled up and scaled down. Okay, if you need you can have some kind of a metric analyzer also. For example, I can make the CPU utilization 80%. If it goes beyond 80%, automatically add one more machine. Okay, if it goes less than 80%, decommission one machine, right? Likewise, I can able to I cannot need not to guess the capacity in advance if it is in the cloud computing environment. Sorry. Okay, fine. So this is what we say, stop guessing about the capacities. So the next point of using the cloud computing is start spending money in running and maintaining the data centers. Okay, if it is an on-premise environment or if you are having your own machines to do the operations in the sense, what do you have to do? You have to maintain everything, right? You need to manage the systems in case if it gets overheated, you need to use some kind of a cooling for the data centers, and everything has to be managed by the user, right? So, but if you are having a cloud, okay, all the management will be done by the service provider. So Amazon will take care of all the heating and every expenses, right? You need to focus only on the application development. What is your purpose of doing that server? You can focus on that, right? So that is what we say. Stop spending money in running and maintaining the data centers. So the next one is global in minutes. If I want to deploy a machine, I can able to deploy in 2 minutes using some kind of a user interface. I can able to click and I can able to host a machine within a 2 minutes in Amazon AWS. So you can global in minutes. And another important thing, what you have mentioned, high accessibility. Okay, I can able to access the data. Okay, anytime, anywhere. Okay, I need not to come to my office location to access that particular data. If it is stored in the cloud, in my home, using my mobile, I can able to connect and I can able to access that particular data, right? And next one is a heterogeneous client platforms. Heterogeneous client platforms in the sense, if you want to access the cloud platform, it does not request any specialized architecture, specialized machine. You can have your mobile phone and you can able to connect with the machine which is hosted in Amazon AWS. Okay, you can use some kind of a tab or mobile phone, okay, whatever the device, okay. So it supports some kind of a heterogeneous client platforms in order to connect with the machine that was in the AWS, right? And resource usage monitored, controlled, and audited and reported. That is, as I already mentioned, the cloud uses a principle pay as you go pricing model. How much time you are using, that much you have to pay for it, right? So there is a concept called resource usage. How much resources you are using, that will be documented, okay? So that if they are making some kind of a charges, you can able to audit them, right? Whether they are making, yes, the last week I have deployed S3 or EC2 and I have used the machine for 10 minutes. That I can able to clearly mention, right? So that is what we say, resource usage, monitored, controlled, and audited and reported, right? So next we are going for a global infrastructure, okay? You have a fundamental understanding about the global infrastructure, then we move on to the Amazon S3, right? So what is global infrastructure in the sense? What do you think? A cloud computing, I'm going to host one machine, whether the machine will be come from the cloud? So where the machine will be? Yes? Okay. Yes. So the primary understanding is the resource will be provided from some facility. Okay. If you are using Amazon, AWS is having multiple data centers across the globe. From the data center only, you will be provided with some kind of a resources. Suppose I'm making one machine. Okay. My machine capacity, I'm telling that 8 GB RAM and 1 TB hard disk. I want a machine to be deployed from the AWS. Okay. They will provide you a machine from the facility that they are having. Only thing you are doing is you are having internet connectivity to connect to that particular machine. After that, everything is with respect to that machine, not to your platform, right? So this is what we say, global infrastructure. If you see the global infrastructure of AWS, Amazon Web Service, it has 36 regions and it has 114 availability zones and more than 700 edge locations. Okay, so the green dots are mentioned as that is regions, and the red color dots are the region it is going to come in the next years. Okay, this is the statistics taken from 2025 only. So it is a current statistics of AWS, right? So you first understand the difference between region, availability zones, and edge locations. Okay, so the first one is a availability zone. Okay, availability zone is nothing but it is a data center. Okay, Amazon is have 114 data centers, okay, across the globe. Okay, so data centers are nothing but, you all know what is data center, right? It is an in-house facility. Inside this building, you will have all the infrastructure components. You will have a server, you will have a compute, you have a switches, load balancers, and everything. Okay, all the in-house facilities will be equipped with some kind of a redundant storage and backup, right? So this is said to be a data center, right? And if 2 or 3 data centers are very near to each other, it will be considered as a single availability zone. Okay, this is the primary thing. Availability zone is nothing but data center. Inside the data center, you will have all in-house facilities, right? So second one is a region. Okay, region is nothing but it is a geographical area which consists of 2 or more availability zone. For example, you take about the South India. South India, AWS is having a South Indian region. Okay, Inside that, they will have the availability zones in Chennai, Cochin, Hyderabad, and Bangalore. Okay, they are the data centers. Okay, where the facilities are available. These availability zones, 2 or more availability zones, are combined together to form a region. Okay, this is what the region. And next important thing is, if you take a region, okay, all the availability zones in the regions are highly isolated from each other. The reason is, for example, if any flood happens in one availability zone, it should not be affected by some other one. Okay, the most important thing is they uses a concept of replication. Okay, the same data will be stored in 2 or 3 different availability zones. In case one availability zone goes down or it is affected from natural calamities, it means that other availability zone should not be affected. That is why they choose a geographically distributed availability zone to combine a region. For example, if they create one availability zone in Kottayam and one in Pala, if anything happens in Kottayam, similarly, it will get a chances that it will affect in the Pala also, right? So there is no purpose of defining the availability zone like that. So they will make the availability zone, which is completely isolated from one to each other, right? And all the availability zones are connected together via high fiber optic cable. Because if you are transmitting the data, that has to be transferred across in seconds, right? In milliseconds, right? So all of them are connected with some kind of a higher fiber optic cables. So this is region, and next one we are going to see is the edge locations. Sir, edge locations are nothing but it is the endpoint of the AWS used for catching the content. Okay, and AWS is having more than 700 edge locations. Okay, we cannot treat edge locations as a region or availability zones. Okay, edge locations are a small facility. Okay, region we see, availability zone is a data center, but edge locations is a small location. Using that location, we can able to catch the content. Okay, so what is catching the content? Any idea? It's just a discussion. Catching. You know the principle of caching mechanism, right? Computer organization also, you see the different types of. Yes. Yes. Yes, please. No need for mic. You please. It's audible. Please. Okay. So caching in the sense, if you want to access the data, okay, much faster compared to that of a normal location, because of its proximity. Okay, cache locations will be very closer to each other. Okay, closer to the user who are making a request. So I can able to access the data much faster compared to that of the normal data, right? So for example, you see, I have built one application. I have built some booking application. Okay, so I have built an application. I have chosen the region as a South India, and I have chosen the availability zone as a Mumbai data center. Inside the Mumbai data center, I have made one machine and I have posted that application. Okay, but after running that application, I came to notice that many of the users who are using that applications are from Singapore. Okay, what happens? It has a long delay, right? Okay, it depends upon the proximity of the place I hosted and the place I am using that particular application, right? So it has some kind of an intermittent delay. Okay, so what I can able to do is, okay, the application will be in the Mumbai. The same copy of the application can be hosted in the edge location, which is nearer to the Singapore region. So the people who are accessing from the Singapore, instead of coming and accessing the data from the Mumbai, they can able to access it from the edge location where the cache content is available. So I can able to get the faster response, right? So this is said to be a edge content. Okay. So I coming to the point. Okay. So I have mentioned that we have regions, we have availability zones, we have edge locations, right? So, so what are the criteria to choose the region? Suppose I build one application, one booking software, I have built it. I want to host that application. So before hosting it, the Amazon or Microsoft Azure, they'll ask you what is the region you want to host it. Okay. So what are the criteria I need to think before choosing that region? I can choose South India. I can choose North Virginia. I can choose UK. I can choose Scotland, Singapore, any region I can able to host it. But some kind of a reason, logical thinking should be there before hosting that particular data, right? So how I can choose it? How I can able to choose this region? I can choose it for my application. What are the criterias? Yes, access. Okay, access your cost. Mostly the services won't differ. If you are putting a server, the cost in UK as well as America and India, all of them are having a same pricing model. But what you say is exactly correct. The access geolocation. Good. Any other factors? Online participants, do you have any answer for the same? Online participants, do you have any answer for what is the factors that motivates to choose? Um, okay, I'll continue. Sorry. Okay. So depending on what? Population. Okay, the populations of people who are using that particular application, right? Okay. Any other from your side? Just a guess, no, no issues. Anything? Okay. So the first one is, as you mentioned, it is correct based upon the response time. Okay. Depending upon the geographical locations, suppose I build the application, I need to choose a region which is very closer to my proximity because it is a data transfer, right? If the time taken for reaching the Chennai facility is much closer to me compared to that of reaching the Singapore facility. So depending upon the geographical location, I can able to choose it. But here also, the most important thing is it should not be based upon your geographical location. For example, I am building one application. The applications which will be mostly used by the Middle East countries. But if you are hosting the application which is nearer to your geographical location in the sense, it is no use, right? So depending upon the people who are going to use your particular forum or applications, you try to host the region. That is the first thing. The second one is data sovereignty laws. Okay, there will be some kind of a federal laws where you cannot able to transmit the data from one country to another country. Okay, for example, you take United States, they won't give any citizens data outside their country. So if you want to do some kind of analysis or you are building some application which uses the US citizens in the sense, you cannot able to host the data center from Chennai. Okay, because they won't allow you to transmit the data to your region, right? So depending upon the data sovereignty laws, depending upon the federal laws of the particular government, you need to choose the particular region. So the next one is related to that of a service. Okay, service in the sense, if you take a cloud computing, okay, lot of things are provided as a service to you. Okay, not only EC2, S3. Okay, you will have services like databases. You will have services like robotics, AR, VR, blockchain. Likewise, multiple services are provided by the AWS, right? But it is not sure that all the services will be available across the globe. Okay, whenever they are proposing a one new service, the service will be available to the most predominantly used geographical location. For example, Amazon is most giving all the services to the North Virginia because it is the first center they have built and it is a very big centers also. Depending upon the populations of the user who are accessing the service, they will spread it geographically distributed, right? So suppose you want to use a specialized service which is related to IoT or AR, VR, you need to choose a region where that particular service is available. Okay, that is also another criteria. So depending upon this, you can able to choose the appropriate region for your application buildup, right? So lot of global architecture and core components are there. And today's session, we are going to discuss only about the durable and fault tolerant storage system of AWS, which is said to be Amazon S3. Okay. And okay. So how many of you store the images or your mobile data in the cloud? You are using, right? Anyone storing your, instead of storing it in your own mobile, because of space constraint, or they are providing some kind of a free 1 GB cloud storage, right? How many of you are using a cloud storage in your uh, mobile phone photos, or your desktop, or even your Google uh, Gmails? You are posting it in the cloud, right? So it will be provided by multiple users, right? Everyone is using, right? So today we are going to see the storage service which is provided from the Amazon, which is said to be Amazon S3. Okay, Amazon S3 is nothing but it is a simple storage service. Okay, why the name comes is simple in the sense the storage service is very easy to use. Okay, it has some kind of a web user interface, just giving some kind of a clicks and everything. You can able to create a storage in the cloud, right? And it is a storage device. Okay, you can able to store your data, any object data that can be stored in S3, and it will be provided as in the form of a service. Okay, service in the sense when you are using that particular S3, you will be charged for the amount of data you are storing and how much time you are retaining the data inside the S3, right? That is why we say it is a simple storage service. Okay, so S3 is a secure, durable, and highly scalable object storage. What is highly scalable? The terminology is important. Okay, when you are dealing with some kind of a cloud environment, whatever the terminology, security, durability, highly scalability. So what is highly scalable?
Depends upon our needs, sir. Like,
yes, based upon the growing data, I can able to extend my storage capacities, right? So now I have created one storage for 1 GB, 1 TB. Tomorrow, 2 TBs of data are incoming in the sense I can able to extend my storage capacity. Okay, that is what we say secure, durable, and highly scalable object storage. And as I already mentioned, it is very easy to use and it has some kind of a web service interface, user interface. Using the user interface, you can able to store, retrieve any amount of data anywhere at any time. That is the most important thing, right? And it is a object based storage. Okay, we have different types of storage, right? We have a file based storage, we have a block based storage, we have a disk based storage like our C colon, D colon. We have a block based storage like HDFS. Okay, likewise, it is a object based storage. I can able to store any objects in the S3 like a image, audio, video, okay, PDF, whatever the documents may be, I can able to store it. Okay, only the static content, dynamic contents is not allowed in the S3, right? And they tell that it is a unlimited storage. Unlimited storage, they are claiming that the facility they are having, that much data you may not have. That is why they are telling that it is an unlimited storage. Okay, and also they are telling that the size is an unlimited storage. You can store 100 TBs of data also, no issues. But individual file should be in the range of 0 to 5 TB. Okay, if you are having a single file greater than 5 TB, you cannot able to store it, right? So the size of the file should be up to the maximum of 5 TB. Okay, but you can able to store 100 TBs of data also, 1000 TBs of data also, no issues with the S3 model, right? And the files are stored in the form of a buckets like this. Okay, I will show you a demo, okay, from my system, how the bucket has to be created and how I can able to make the access control, right? And next thing is, it is a limitless storage. It is a flexible pricing in the sense, depending upon the class of storage you are choosing, you will be charged. Next one is accessibility. Okay, it is highly accessible. Whenever you are storing data in the S3, you can able to fetch anytime, anywhere, at any location, right? And it is also having some kind of a control mechanism. Control mechanism in the sense, we have access control list. Based upon that, I can able to restrict who are all the users who can able to access my object, right? I can able to make some persons can able to access the read permission of my object. Some of them can able to do the write permission. Some of them can able to delete. Likewise, I can able to build a policy which is said to be access control list. And from that, I can able to define who are all the users who can able to access which object and what is the maximum permission they can able to get it, right? So during the demo, we will see it. Okay. So how the bucket look like this? Okay, you can able to see that the bucket is consider this is a bucket. Okay, I have services S3. When you are going inside the S3, you need to create a bucket. Inside the bucket only, you need to store all your objects. Objects in the sense, files, your image, okay, your audio file or PDF file, whatever it may be, it is said to be an object. This object should be stored inside the buckets and you need to create a bucket. Okay, So bucket is said to be a basic container in S3, and inside that I can able to hold files and objects. Okay. And one more important thing is bucket name when you are giving in the S3, it should be universally global. Okay. Because it should be unique. Okay. Throughout the globe, it has a common name. Your bucket name should be unique. It's a primary key compared to that of the other person's bucket, right? So it should be universally global. Okay. And so objects in the bucket will have these following entries, right? So for example, you see, I have one JPEG file, okay, which is said to be a trip.jpg, okay? And I'm going to store this trip.jpg object into a bucket, okay? And if you see, the trip.jpg is the object, okay? So object will consist of these following informations. One is a key, another one is a value, another one is a version ID, next one is a metadata, and next one is a sub resources. Okay, key, value, version ID, metadata, and sub resources. Okay, key is nothing but name of the object. Okay, so here what is the name of the object? It is trip.jpg, right? So the photos is a bucket name followed with one folder 2021. Inside that I am having an object, my image file, which is said to be a trip.jpg, right? And what is the value? Value in the sense it is an image file. So it is a binary data, right? It is a binary data. And we have a version ID for each and every object. Version ID is used for recovery purpose. For example, when you are preparing some kind of a documents, you will create multiple versions, right? First initial draft you are preparing. After updating, you are making version 2, version 3, likewise. Okay. So the ultimate objective of versioning is, even if you are losing your object, okay, based upon the previous versioning, version number, I can able to recover that particular object and I can able to use it. Okay. That is why the versioning is, if you want to use this service, you will be charged. Okay. So next one is a metadata. Metadata in the sense, the information related to the trip.jpg. So informations may be what type of content it is, what is the length of that content, when the content was last modified, when it was last assessed, right? That is what we say. Content is 1024 is the size, and you have a last modified on 30th November 2020, right? This is how it looks like. I'm giving this explanation because when you are going for a demonstration, you need to understand what it is, right? And next one is, this is the bucket. Okay, this is the folder I'm having. This is the file I'm having. I want to store this file into a bucket in S3. Okay, via internet, I can able to transmit that particular data and I can able to put it into the bucket, right? That is what it is mentioned. But if you are using, application way, okay, when you are submitting a request, when you are receiving a response as HTTP code 200, it assumes that the upload is successful. If you are using a user interface, you can able to see it, right? Because user interface, after uploading, you can able to see that file is inside or not. But if you are using a SSH or a command way, you are uploading the particular data. That time, if you are receiving the HTTP code as a 200, it indicates that the upload is successful. Okay. And once it is uploaded in the S3, you can able to download the data anytime, whenever you want. And also you can give some kind of a permission to the other users. Okay, can also be able to download that particular data, right? And the permissions can also be enforced. Permission in the sense, who are all the users who can able to access this particular data? What is the maximum level of permission that particular users can able to do it? Whether they can able to read or delete, or they can able to do both the operations, all right? And next important thing in S3 is a data consistency model. So what is data consistency? Anyone? Yes, what is data consistency? Why it is needed in the a storage platform or a cloud environment? A lot of researches are going on this data consistency model. Any idea? Data consistency? As I already mentioned, the terminologies plays a significant role in the cloud computing paradigm. Okay. So what is your understanding, please? Consistency. Okay. Any other answers? Okay. Suppose I have a bank account, okay, and I'm checking my bank balance. Okay, it is showing that my bank account balance is 50,000 rupees. After 5 minutes, I'm again checking my balance. I'm not doing any operations. But that time it's showing 40,000 rupees. So the data is inconsistent. The model you have built is inconsistent. It shows different results. It is not consistent in nature. It shows different results whenever I am assessing that particular data in different time, right? If anything happens in between, because of that 40,000 it was reduced, I can able to understand it. Similarly, you think about a situation in S3 itself. I have created one bucket. Inside that, I have put it my face or my image, right? I open that image. Instead of my image, it comes some other person's image. So what happens? The data is not consistent, right? So what is the data consistency model that they are using in S3 is, okay, there are two different consistency model. Okay, one is a strong consistency and another one is a eventual consistency. Strong consistency in the sense, once the update is happened, immediately you are referring to that particular data, you will get an exact result. That is said to be a strong consistency. Eventual consistency in the sense, okay, the update is, okay, whenever the update is happened, okay, after that you are referring to that particular data, but the update is not reflected immediately. It takes some kind of a gradual time to get reflected in the storage medium. Then we say it is a eventual consistency, right? So what they are telling is, okay, read after write consistency for a puts of a new object. That is, okay, I have Amazon S3. Okay, I'm going to put in the sense I'm going to insert one object inside the Amazon S3. Okay, after inserting, immediately I'm doing a reading operation. Okay, if I perform a read operation, it is strong consistency. Okay, I inserted one image, immediately I make a read, I will get 100% consistently what I'm uploading. But they are telling that in case if you are doing some kind of a update operations, okay, update in the sense overwriting the existing image or overwriting the data which is present in the object, right? Or if I'm performing the delete operations, immediately after that you are making some read request in the sense, you will not get a strong consistency, you will get a eventual consistency. That is, there is a high chances that it won't get reflected immediately. Okay. For example, I have my image trip.jpg. Okay. After that, I'm performing a delete operation. After deleting, I make a request, right? But there is a chances that the data may be available in the storage because it is not a strong consistency, it is a eventual consistency, right? So this is what the data consistency for S3. Okay. So with this storage class, I will go for a demo. Okay. So the next one is a storage class. Okay. This is also something related to the theoretical concept. Okay. Please understand it. Then only you can able to choose the most effective options for your data to be stored in the cloud platform, right? So what is storage class in the sense? Storage classes are data storage options which are provided by the Amazon S3 based upon your specific requirement or use cases. You can choose any one of the storage classes. Okay. So what are the factors you need to consider is what is the access frequency of the data? Whether I will access the data immediately and again, okay, or based upon the data retention, how much long I am going to store that particular data in the cloud platform, based upon the performance and based upon the cost criteria, right? So I will give a comparative study of different storage classes. Okay, if you understand it perfectly, you will get a good idea about what are the different storage classes. Okay, the first storage classes is a S3 standard. Okay, standard in the sense, okay, by default you will be allotted with this particular storage class, right? So this storage class is having 99.99% of availability. That is, if you are accessing the data, it will be available 99.99% available. And what is the durability they are giving is 99.11 nines. That is, that much time the data will be retained, right? And in this model, standard model, whatever data you are uploading, that will be replicated and stored in 3 different data centers. What is the reason? They are replicating and storing in 3 different. Yes, parallelism, fine. Any other? Most important thing. Why I have uploaded my image into the S3? I have chosen a single region only. But whenever you choose a region, the data will be stored in 3 different availability zones, 3 different data center. Fault tolerance. Okay, even any particular data, my image goes down in one facility, I can able to recover that same data from some other facility, right? So they ensure that even two loss of facilities concurrently, I can able to recover. So what is the logic they are following is my data will be replicated and stored in three different centers, three different data centers. This is the standard model. Okay. You can by default, if you are choosing bucket and you are choosing object in the sense, you will be directed to the S3 standard. But there is another storage class also. Okay, you need to take a decision based upon your organization requirement, which storage classes will be more appropriate for your use case, right? Second class is said to be a infrequently assessed data set. For example, I have a data. I feel that the data may not be assessed frequently. Okay, it will be very infrequently. I'm going to assess that particular data. Then you can able to choose this storage class. Okay, this cost of the storage class will be much lesser than that of the standard model, but you have to be more aware that my data will be assessed very less frequently only. Okay, because you will have some kind of a retrieval fees if you are making some kind of a request in this storage class. Okay, so you need to take a decision before. Okay, if I feel that my data may not be assessed more frequently in the sense, you can choose it. But after choosing this class, your data is more frequently assessed in the sense you are having some kind of a retrieval fee, right? Because of that retrieval fee, you will be charged more than that of the S3 standard. Okay, that is the most important thing. And we have another storage class called one zone infrequently assessed. As the name itself, we can able to understand that the data will be placed in a single availability zone. Previously, I told the data will be placed in 3 zones, right? Even 2 losses, I can able to recover my data. But if you are choosing this storage class, data will be stored in a single machine only. Okay. So if you feel that my data, I have a backup in my machine, so even the data is lost, I need not to worry about the scenario. Then you can able to choose this one zone infrequent losses, which will be much lesser than that of these two models, right? The last model is a intelligent tiering model. It is a service provided from the Amazon S3. So if you are choosing an intelligent tiering model, this has some kind of a predictive mechanism. It understands the nature of your data. Okay. And based upon that, it chooses the platform, which model will be more appropriate for your application. Okay. It chooses that, okay, you are having a more frequently assessed data. So all the data can be moved to the S3 standard. After some point in time, your data is not frequently assessed in the sense, it takes an intelligent decision of moving your data from the standard to the infrequently assessed in order to achieve some kind of a cost efficiency. But it is a service, right? It is a predictive modeling. It is a service provided to you. So because of using this service, you will be charged, right? And another two services are there, which is said to be a Glacier and Deep Archive, right? Glacier, this is both the models are used for, storage classes are used for archival storage. I have some kind of a backup data. I need to store it. Then you can go with either Glacier or Deep Glacier, depending upon your requirement. These two models are very cost effective. Okay, 10 times to 100 times cheaper than that of these models. But the problem here is, okay, the retrieval time will be minutes to hours. If you are choosing the storage class, that is Glacier, you are uploading your image into the Glacier model in the storage class, and you are making some kind of a read request. I want to open that image. It takes minimum of minutes to hours in order to fetch your data. But in these cases, everything will comes in milliseconds. If you are clicking it, you will get the response immediately, right? And Deep Archive is also another storage medium. They will put it in some repository which is very far, and they are putting here. Here the retrieval time is around 12 hours. Even if you are submitting your request now, you will get your image back after 12 hours. But it will be a very cost effective solution. And if you feel that I don't require this kind of a fast access, then you can able to choose it. So it is completely related to that of your organizational use cases. You can able to choose whichever medium is more appropriate for you. You can able to choose it, right? And these are all some things, and I think that is not mandatory to understand. Let us see some kind of a demonstrations. Let us see some kind of hardcore stuffs so that you can able to understand in a better way, right? So I will try to show you a demo. Okay, what I'm going to do is I'm going to create a bucket. Inside the bucket, I'm going to store some kind of objects. Objects in the sense my file. I'm going to take one image file and I'm going to store it. Okay, and after creating it, I'm going to block all the public access. Okay, storage will be there. As a user, I can able to download it, but I am going to restrict with the public users. Okay, so let us see. Actually, I stopped it. Log into the S3. After that, I'll share. Okay. You see here, so I have one object here, one image file here. It is set to be a flyer.png. Okay. So I'm going to upload this particular object into Amazon S3. So the first step is I need to create a bucket. Inside the bucket, I need to upload my object, and I need to block all the public access so that the other users cannot able to download or read my particular file. Okay, let us, after the demonstration, I will show you how it can be made as a public access so that every user can able to download it. Next, we will see about the bucket policy. In that, we will define who are all the users who can able to read that particular file, who can able to delete that particular file. Okay, and okay, so this is my AWS account. Okay, this is my home page of my AWS. So this is what I told, right? This is the region in which I am currently. Okay, so whatever resources or whatever services I'm using, that will be hosted from the United States, North Virginia, right? I can able to change that location also. Okay, depending upon the, you have Mumbai, Seoul, Singapore, Sydney, Tokyo. Likewise, different regions are also available, right? But I am going with the North Virginia. It is not. You can able to use it. Any region you can able to deploy it, right? And here I am having a S3. Otherwise, you can search S3 here, okay, which is said to be object storage. I'm opening the S3. Okay. Currently, I'm not having any S3. Okay. You go through this particular video also later if you want to understand the diagrammatic representation or some animation videos will be there. So it will be very easy for you to understand also. So the first thing I'm going to do is I'm going to create a bucket. Okay. So you can able to see that the bucket I'm going to create in this AWS region, US East, North Virginia. So in the North Virginia data center, one bucket will be created. Inside that, I'm going to store my file, right? And bucket type, I'm going to use it as a general purpose bucket. Okay. After that, I need to specify the bucket name. This is what I told. The bucket name should be universally global. Okay. So it should be a unique value. Otherwise, I cannot able to create a bucket. So try to give some kind of a good name. Bucket 4949. Okay, this is my bucket name, right? After that, I'm going to make the access control list disabled. Right now, we make the access control list disabled. Later in the third demonstration, I will show you how to make it as an enable and how I can able to write a policy using the policy, how I can able to access that particular data, right? So the next one is block all public access. By default, it will comes with a block all public access. That is, S3 follows a principle called least privilege principle. Okay, so it will comes with some kind of a basic all access will be blocked, and you can able to give access depending upon your requirement. Okay, they won't make all the things available to everyone. They make some kind of a restricted, which is said to be a least privilege policy. Using that, all the things will be private as of now. If you want to give restriction or permission to any person, that you can able to configure using ACL, right? That you will see. So you need not to change anything. Block all public access. Okay. Bucket versioning, default encryption, what encryption algorithm they are using, and everything. You can create a bucket. As I already mentioned, it is having some very easy user interface. Everything was, a brief description was also given. Even if you are not able to understand what it is, you can able to read it, right? So the bucket is created. You can able to see that the bucket name is Venki-bucket-4949. I'm going inside the bucket, and inside the bucket, I'm going to upload a object. Okay. So here upload option is there, right? I have to click. I'm going to add files. I'm going to add this flyer.png. And I'm going to upload it. So you can able to see that this flyer.png was, this is an object, my image file that was uploaded inside a bucket. The bucket name is Venki-bucket4949, right? So if I click here, so if I click here, you can able to get all the information related to that particular object. What is this file name? Which region it was hosted? What is the size of that particular file? Okay, and you will get some kind of a object URL link. Okay, you can able to share this object URL link so that the other users can able to see this particular file, right? There are some static websites that will be hosted in S3 and the link will be shared to every person, right? So whenever you are building some applications, you are building some static website, you are building some images to be shared with everyone, right? You upload the image and you can able to share this object URL to your friends so that they can able to see it, right? So now I can able to share this object URL. I think you can also see any groups you are having. Okay, fine. I will show from my side, right? So if I click this object URL, you will get the option like access denied. You cannot able to open this particular image. What is the reason for that? Yes. So by default, it comes with a least privilege policy that all the buckets and data inside that particular S3 will be a private mode. Okay. Unless you are explicitly mentioned or unless you grant a permission to the system, it will be in the public mode, right? Sorry, private mode. Okay. Let us see how it can be modified. So you hope you have understand how to create a bucket in AWS. Inside that, how to upload an object. Okay. When you are sharing the public URL, you will get a access denied because of the reason of least privilege policy, right? So now you see, understand what is access control. Okay. Using the access control, how I am going to modify in the next demonstration. All right. So access control in the sense, okay, it is securing the data, ensuring that only the authorized users and system can access your buckets as well as your objects which are present inside the bucket, which is said to be access control. So access control can be applied to two different levels. I can able to apply the access control on the bucket level, okay, or else I can go inside and I can able to apply the access control on the object levels. Okay, suppose in bucket I have 100 images. Out of 100 images, I can make 30 images as public, 30 images as a private also, right? So if you are imposing a bucket level control, okay, this control assesses the entire bucket. Okay, they define which AWS accounts or users or groups which can be granted permission, which can be granted which type of a permission, like a read permission or a write permission, right? This is the bucket level control. Similarly, if you're taking an object level control, these are applied to the individual objects or images or files that are present inside the bucket, right? This allows you to control access to the specific object independent of the bucket level control. Okay. So this is said to be a bucket level control and object level control. As I already mentioned, all the objects in the S3 bucket are private unless you explicitly grant permission to them. That is why I clicked the object URL, but I could not able to see the image of that image that I have uploaded, right? Because it follows the principle of least privilege. That is, it always grants the minimum permission necessary for a user or application to perform its task. right? So if you see the access control, okay, that I have make the flyer.png, right, which is inside the S3, right? If you open the permission tab of that, you can able to see the access control list. This is how the access control looks like. Okay, you can have the access control list. You will have who are all the grantees, and for that particular object flyer.png, which user is having which kind of a permission. Okay, this is the first is a owner, that is my user ID, right? My user is having a permission to read that particular object. If you take other public access, it is having no permission. That is what it is mentioned as a dot, right? So if you have a permission, it will be mentioned as a read or write. Okay. If you are not having any permission, it will be mentioned as a not applicable, right? So this is how the access control list looks like in the Amazon S3. Okay, it has some kind of a grantees. Grantees are nothing but who are all the users. Okay, who are going to use that particular object, and this is the permission that we are going to grant it for the grantees. Okay, it is having a read permission, write permission likewise, right? And let us see in the demo. So the second demo, what I'm going to show is I'm going to create a same bucket, but now I'm going to make the objects publicly accessible in the Amazon S3 using access control list, right? So I have an object, same flyer.png file I'm going to take. I'm going to store it in the Amazon S3, the same thing, but in between I'm going to write an access control list. In the access control list, I'm going to define it is publicly available to everyone, so that all the users can able to download and see the that particular object, right? So you create a S3 bucket. After that, upload an object. After that, configure the ACL for a public read. And after that, you can able to access the object through URL. Okay. So you see here, I'm going to the buckets. I'm going to create a new bucket. I'm not going to use the existing one. I'm going to create a new bucket. So the bucket name I'm going to give is Venki-public- bucket. It's a user defined name, but it should be unique 4949. Okay, so I'm giving. Okay, after that, I need to make ACL enabled. Previously, I have make ACL disabled, right? Access control list disabled. Now I want to make the access control list enable so that I can grant permission to everyone to access that particular data, right? So I'm going to enable the ACL. I'm just enabling the ACL. After that, I need to untick block all public access. Previously, I have make tick of all public access. That is why the public forum cannot able to access my object. Now I am going to untick it. Okay. Once you untick the public access, block all public access, it asks for some kind of acknowledgement, because you are storing the data, but you are not storing it in a private way. You are making it is publicly available, right? So it asks for the acknowledgement that are you sure that the data may be available in the public forum or not? Okay. So I'm giving an acknowledgement to here. And then remaining the same. And I'm going to create a bucket. So only change I have done to the existing bucket scenario is I make ACL enable. After that, I have unticked the block all public access, right? So I have created one more bucket. I'm going inside this particular bucket and I'm going to upload a file, upload an object. Okay. I'm going to add files. I'm going to choose the same file, flyer.png. Okay. And then in the permission, you need to grant public read access. Okay. Previously it was not there, but you have to go to the access control list and give grant public read access. Whenever you are giving grant public read access, it asks for some kind of acknowledgement from you. I give the acknowledgement also. And then you are having a properties. Inside the properties, you can choose what kind of a storage medium that particular object requires. We have seen, right? We have seen different storage medium, right? Standard, intelligent tiering, infrequently accessed, one zone infrequently accessed. Likewise, you can able to choose it. By default, it comes with a standard policy. Okay. Then I'm going to upload it. Okay. Now the flyer.png, the object is added. I'm moving inside this particular object and I'm clicking this object actions and I'm making public using ACL. Yes. Okay. So now the same thing. I have created a bucket. I have uploaded an image. But only thing I have did is I have enabled the ACL access control list. And inside the ACL, I make all the data publicly available. Okay. So now the same object URL is here. Okay. But if I click this object URL, I will get that particular image. You can able to share this particular URL to anyone. Okay. Even if I share that URL to you, you are opening from your mobile or whatever it may be, it is publicly available. You can able to download it. Okay. That is a primary difference between the first demo and second demo is first demo, I have go with some kind of a default configuration where my object will be available private mode. You cannot have, the outside world does not have any permission to access my data. Second demo, what I showed is I have created one access control list. In the access control list, I make the data will be available to the public. Okay. So if you share this URL, you can able to get it. So if you are hosting any application and make it available, anyone can able to use that particular application and submit their task, right? They can able to perform it. So the third demo, what we are going to discuss is, so two aspects we have discussed. One is making everything is a private. Second one is making everything in the public. Next one, we will see, we will have some kind of a bucket policy. We will define or write some kind of a bucket policy in such a way that some users can able to perform read operation. Okay, some users cannot able to perform the delete operations. Okay, so I make some with respect to the operations. Okay, I make everything public to everyone. Okay, but if you want to read this particular file, you can able to read it. But if you want to delete that particular file, you cannot able to delete it. Okay, that is what we say bucket policy. So the next security aspect with respect to this set to be a bucket policy. Just 1 minute. Any doubts? Okay. Let us complete with this demonstration, right? So let us discuss how the bucket policy can be written. Okay, you need not to write from your basic thing. Okay, we have some kind of a generator in S3. You just give the context what you want. Okay, you just give that. I want to block the public access for deleting that particular file. You just give, I want to permit all the users to read that particular file. Likewise, if you are giving the context, the generator will generate this kind of a JSON script for you. Just copy this JSON script and put it in the bucket policy folder. You will get the, it will be enabled, right? So it will be more user friendly for using this particular scenario, right? So the bucket policy is nothing but bucket policy provides a way to control access to your Amazon S3 buckets and objects within them. Using the bucket policy, you can specify who can access the data and what kind of actions, whether it is a put action or get or delete. Put in the sense insert, get in the sense reading, delete in the sense you are deleting, right? what kind of actions they can able to perform under which conditions. Okay, that all the things you can able to specify using the bucket policy. Okay, you will get a fine-grained control, resource sharing, and enabling the public access is possible when you are defining the bucket policies, right? Here you can able to see the bucket policy. From this bucket policy, can able to understand or interpret anything? What it is written? Yes, just the interpretation. It is very clear, right? It is a human understandable format. It is. Yes, it gives read access to the public. It gives
Source.
great. So what is this? Resources. This is the bucket I have created. Okay, and you have different fields like SID. SID is nothing but it is a identifier for the name you are giving. It's a user defined name. Whatever name you want to, you can give it. But understandable name you try to give it. Otherwise, the policy it is very hard to interpret, right? So you have a effect. Effect in the sense you have two options in effect: allow or deny. Okay. So allow or delay corresponds to the action that I'm going to perform. Okay. So actions is in the sense here I am giving S3 dot get object. Get object in the sense I'm going to read the object. Okay. From S3, whether it is allow or deny, I can able to map it with the effect. Okay. So read object is permittable and the principal in the sense the user who are going to use it. Okay. So I'm giving a user as a star. Star in the sense it's a global user. Every person who are accessing that they can able to use it, right? And then which resources they can able to read it in the sense the resource bucket name I am specifying here. This is the bucket name I have created. Inside the bucket I am storing the object, right? So I am specifying what is the bucket and I'm specifying what kind of action that going to do. Going to do is a reading object, reading the file, and who are all going to read? All the users, and whether the effect is allow. Allow in the sense all the users will be allowed to use a particular bucket, right? Similarly, if you are taking a one more uh, what we say a bucket policy is I am denying for all the users to delete the object from this particular bucket, right? So both the things using the policy generator is there in Amazon S3. If you are giving, it will generate code for you. You need not to write. If you are more comfortable, you can able to write it also, right? So let us see a demo. Okay. So here we are going to create a bucket policy to allow the read operations, and I'm going to deny the delete operations for all the users. Okay. So I have a user who is going to upload one bucket, who is going to upload an image in Amazon S3. I have defined a policy. In the policy, I'm going to allow to read object from all the users, and at the same time, I'm going to deny to delete that particular object for all the users, right? So how it has to be done? Let us see. So again, I am going to the bucket. So I have two buckets. The first bucket is everything is private. Second bucket is everything inside that it will be a public. Third bucket I'm going to create, and that bucket permits all the user to read, but it denies all the user to delete it, right? So I'm going to create a bucket. The bucket name I'm going to give is Venki hyphen policy hyphen bucket. It's a user defined name. You can give any name, but it should be globally unique. Okay, Venki hyphen policy hyphen bucket hyphen 123. Okay, and I make ACL disabled, and I'm going to unblock all the public access, and I'm creating a bucket. It's a very generic way. What we have followed in the previous demonstration. Same thing. I have created a bucket. Yes, some acknowledgement is required because I'm untick the block all public access, right? So create bucket. It is loading. Network is there, right, sir? Internet. Wi-Fi. Okay, I will do it from scratch. So again repeating the same step. It was winter. Okay. So I'm defining the bucket name. I make ACL disabled. I remove the block all public access. Since I removed it, it asks for some kind of a confirmation. So I give some kind of acknowledgement. After that, I created a bucket. Yes. So you see here, I have a bucket which was created successfully. The bucket name is Venki-policy-bucket-123, right? So inside the bucket, I'm going to upload the object. Okay. The same file I will upload here. I'm just uploading the flyer.png. I'm choosing the properties as a standard format in order to store that particular flyer.png. After that, I make a upload option. Okay, now you can able to see that inside my bucket, S3 bucket, I have uploaded the flyer.png. Okay. And if I click the object URL, you can able to see that the permission is denied because it comes with the default bucket policy. Now only I am going to update the bucket policy to make the data will be available for read operation and it is denied for the delete operation, right? So how to update the policy information in the bucket? You just to open this bucket, Venki-policy-bucket123 and go to this permission tab. Click the permission tab. Okay. Here you have a column called bucket policy, right? Here that policy which I have shown in the presentation, right? That policy has to be copied and it has to be pasted. Otherwise, okay, so I'm just clicking the edit option. Okay. So for your demonstration, I'm just copying the bucket policy. You can able to see the same bucket policy. I'm just to copy this bucket policy and I'm going to paste it here. Okay. So the bucket policy is having two statements. The first statement is it allows all the user to read the object. Second one is it denies all the users to delete that particular object. So I am just updating the bucket policy. If you are not comfortable in writing the bucket policy, you have a concept called the policy generator here. You click that, and inside the policy generator, you just give the context what you want. Automatically, the policy will get generated, right? I will show you demo also. Okay. So here, just to verify that this ARN what you have given is, and this one is same, right? And I'm just making the save changes. So now what I did is I have uploaded the object. The object URL is here. But previously, if I click this particular URL, it does not give the open permission, right? But now I have updated the bucket policy in such a way that it makes publicly available to all the users. So if I now click it, I will get that particular image, which is loading. And if I do some kind of a delete for this option, it won't allow me to do the deletion. Okay. So I will show you from the command prompt, because every time you are not exposed to the user interface, right? Sometimes you need to interact with the object storage using some kind of a command line interface. Okay, from that you need to write the code, and from that you need to access the data and you need to process it, right? So I am going to just open the Cloud Shell. So it's connecting to the Cloud Shell. It's a command line interpreter for connecting with the Amazon resources. Okay. Just I want to show using the command prompt that I make a read request from the command prompt. It should show the file that I have updated the bucket policy. And after that, I make a write request or a delete request. It should give some kind of a deny request for my command line interface, right? Yes. So you can able to see here. Okay. So here you see in my command prompt, I'll give just ls. What is the command ls corresponds to? List all the items which are present in this particular directory, right? So if I give ls, it does not have any files, right? Now what I'm going to do is using command prompt, I'm going to access the data which is stored in my S3 bucket, not in my local machine. I'm going to use, or I'm going to refer to the object which is present in the S3 bucket, right? So the syntax is you need to give AWS S3 and then you have to give ls. Okay. And then you need to specify the bucket name. What is the bucket name? Yes, this is the bucket name, right? Go to the properties, you can Venki policy bucket 123, right? S3 : / and Venki policy / bucket 123. So now what will be the output I'm getting? I'm giving the command AWS S3 ls. Previously I have put ls. My local machine files will be there. Now I'm going to list the files which is available in the S3 directory, and this is the location of my bucket I have given. So what will be the output I'm getting? Flyer.png, right? Because in that bucket I'm having only one file, that is flyer.png. You can able to see that flyer.png. So it is clearly evident that if I make some kind of a read request from the command line, it is giving the permission to read that particular file. Okay. So now what I'm going to do is I'm going to make a delete request to delete that particular file which is stored in the S3, right? So what is the command for delete? rm, right? Instead of ls, I'm going to remove the same bucket S3 Venki policy hyphen bucket 123, and I'm going to delete that particular objective. I'm going to delete flyer.png, right? The spelling is correct, right? Flyer.png. So if I run this command, what will be the output? Access denied. You can able to see that delete failed because some kind of a access denied is happening, because in my bucket I have updated the policy in such a way that if anyone is performing delete request for my object, don't allow, right? If they are making a read request, please allow. That is why you are getting this particular data, you are not getting this particular data, right? Hope you can able to understand, right? I actually, the time is up, and if you have any doubts, you can please ask. Yes, please.
Sir, here we are the owner of that S3 bucket, sir.
Yes.
So don't we have read and write for delete access?
Yes, if you are assessing, okay, so this flyer.png, right?
Yes.
But this flyer.png, you are assessing from this particular machine, okay, not LS. Okay, what I am assessing is my EC2 instance, my cloud instance. What the data is present is my S3 account. Both are different. Okay, so as a public user, as a owner of this particular data, you have a provision to read, write, delete, because you are inserting, right? So you can go to the user interface and you can able to update the policy also. For example, here the policy was written by me only, right? So if I want to delete the policy, I can able to do it. So Venki policy. So I'm going to the permission, and I have inserted this bucket policy, right? I can able to edit it, I can able to delete it. Okay, everything I can able to do it as a root user, as a owner who can have the access to this particular data, I can able to do it. But if you are accessing the command prompt from any of the EC2 instances, you are not permissible to do it, right? For example, here I'm deleting it. Okay, and then I want to show you the policy generator also. Okay, so the policy I have copied and pasted, right? Instead of that, you can use the utility called the policy generator. Using the policy generator, you can able to use the same policy, what I have there things. So select the type of policy. I'm going to choose S3 bucket policy. Okay, and what is the effect? We have seen, right? Allow, deny. Two effects are there. I'm going to give allow, and the principal I'm going to give it as a star. So all the users can able to allow this particular thing. And actions, okay, I'm going to give get object. Not sure where it is. Get object is there, right? Get object in the sense it is a reading of that particular file. Okay, and Amazon resource name you need to mention, right? This is the most important thing. Okay, so this is my Amazon resource name, ARN-AWS Venki policy. I need to copy in your system, it will be there. Just copy it. Okay, and add statement. Okay, and generate the policy. You can able to see that the policy for that same thing I have shown to you, it was being generated, right? So it shows what is the action, what is the effect, what is the principle, what is the resource. Only the order is changed based upon what I have shown to you, right? Remaining everything seems same, right? And any other questions?
So whatever policy we are giving, it also applies for the owner too.
Yes.
Yes, sir. Sir, for
When you are assessing that particular application.
yes, sir.
But you have a user interface where you can able to log in and you can able to update the policy. Okay, that is also possible. But once you think about a situation, you are building one application and you are hosting it, you are fixing some kind of application logic, right? It will be applicable to everyone in the sense owner is also having the same kind of access rights, right? Same thing.
So in the principle, you have given star for all the access, sir.
That you can able to restrict it.
Sir,
Instead of a star,
yes, sir.
you can give the specific user ID, Amazon resource ID, or a specific account ID of a particular user to access that particular resources.
Sir, if,
Or else, I'm just coming to your point, that or else you can create some kind of a groups. In that groups, you can able to give all the account IDs, and I can able to give that particular group as a reference for that. For example, if you are having an organization, you will have multiple hierarchies, right? What you can do is the HR section, all the employees groups you can able to create, and you can able to give the permission like HR peoples can able to delete it. But in the organization, the developer team is also there. At the time, you can able to make a deny request that the developer cannot able to access that particular data or delete that data. Likewise, you can able to frame according to your organizational requirements.
Thank you, sir.
Yes, ma'am.
Hello. Oh, anyone online have doubts? Please come forward. Either you can unmute yourself or come up in the chat box. So no more doubts, I guess. So we sincerely thank Sir for delivering a thought-provoking and highly informative session as part of our FTP. Your in-depth knowledge and engaging presentation have provided valuable insights and enhanced the participants' understanding of the subject. We are truly grateful for your contribution and look forward to your future opportunities to learn from your expertise. Thank you, sir. Okay, offline participants, we have tea served outside. Our next session will resume after 10 minutes. Welcome back, everyone. We are now heading into the final session for day 2 of our one week faculty development program on secure cloud AI distributed systems. It's my privilege to introduce our esteemed speaker, Dr. Adria B., who's an assistant professor at IIIT Kottayam. She secured her PhD from GUSAT. She secured first rank in MTech from GUSAT. Her research interests are health informatics, medical image analysis, data analytics, natural language processing, machine learning, and deep learning. She was also a research intern at the School of Informatics and Computing, Indiana University, USA. She has published many articles in international journals and conferences. She's also a reviewer of many journals like Multimedia Tools and Applications, Journal of King Saud University, Computer and Information Science, Journal Big Data, etc. Over to the session. We welcome you, ma'am.
Okay, so good afternoon all. So am I audible? Okay. So first of all, thank you very much for your introduction. So today's my topic is leveraging AI and ML for cloud security. Okay, I hope the many people are there in online also. So first of all, before beginning, let me ask you, have you had any experience on doing AI ML models or anything like that? No. Anyone in online? No answer coming. Okay. Anyway, um, This is the agenda for today's session. Introduction. So first few slides, I'll be talking on some introduction part. What are the key cloud security challenges? What is AI/ML? What is its role of AI and ML model in cloud security? What are the key benefits by adopting AI/ML tools in cloud security context? Then I move on to some fundamental of AI and ML models. Then what are the challenges? Still, there are many more benefits in AI ML model in applying security part, but still there are many challenges. And what are the future directions? Conclusion, and we will see small implementation part. Some hands-on session also we will see. Yes, 1 minute. Yeah. So as an introductory note, I can say that ICAC's recent State of Cybersecurity 2024 says that more than 4 in 5 cybersecurity professionals feel more stressed due to increasing complexity of threat environment. Okay, ICACS is a certificate consortium for cybersecurity certificate courses. And over half of the cybersecurity teams are somewhat or significantly understaffed. Okay, so these two points making many organizations think about including AI tool for cloud threat detection, anomaly identification, or compliance breach monitoring, etc. So AI-powered machine learning tools are now in very much popular in organizations to detect various cyber threats. Okay, security cloud as well as cloud threats. So, so AI-powered tools are how it works. So AI/ML models basically it works on some data. Okay, so these works on some data to detect new attack based on mostly industry threat profile. Okay, so what I said, ML models work on basically on data. Some data is needed. Some historical data is needed. Historical data in the sense, in the past, how the attack happened, what are the different attack happened. So that those profiles we collect. And on those database, we create some models so that the company or the model can analyze the new trends, new patterns of attacks, and it can foresee some future attacking patterns also. Okay, so now let us see what are the key cloud security challenges. Okay, nowadays many organizations are migrating to cloud platforms. Okay, they are migrating their workload to cloud platform, but still the same time the challenges are also increasing because of the volume and velocity of data, complex and distributed environments. So these are all leading to sophisticated cyber threats. Okay, so they are storing large amount of data, sensitive data. They are more vulnerable to breaches, hacks, threats, etc. And this cloud's decentralized nature and shared infrastructure. All these factors creating the complexity for both security and performance optimization. Now what is AI and ML? Its role in cloud security or cyber security. So AI means it simulates the human intelligence to make decisions. Okay, so we are trying to imbibe some intelligence into detecting the attack. Okay, so that human intervention can be reduced. Okay, some use cases you can see. So these are some use cases now AI/ML models are applying to the security part, like threat intelligence and prediction. Okay, real-time anomaly detection, automated incident response, user behavior analytics, malware detection and classification. So these are some of the use cases where we can apply ML models. So these you can note it down if you are interested. You can explore more on these use cases, how we can address these challenges using AI ML models. Okay. Now, what is its benefit? What is the difference of AI model against traditional security measures? Okay. Say for example, traditional security measures like firewall or intrusion detection system, they are all rely on predefined rules to detect the threats. Okay. They have some set of predefined rules. But AI/ML system can analyze vast amount of past data. That's what I told earlier. We will have the we have to collect many historical data. Okay, so it can analyze, but manually it is not possible to analyze last 15 years or 10 years in an organization. Okay, so but the model can automatically analyze this vast amount of data in real time. Okay, dynamically also it can analyze and can identify the patterns, and it can predict or forecast the new trends and the threats, and it can automatically adapt to the changing pattern. So AI driven system stay ahead of the attackers, okay, providing more dynamic and proactive protection. So these are some of the key benefits, like what I said earlier: proactive threat detection, reduced false positives, faster response, okay, scalability for large environment, continuous learning and improvement. These are some of the key benefits if we apply ML models for cloud security. So far we have seen what is the need of this. Okay, what are the benefits by applying ML models? Now let us move on to some fundamentals of AI ML concepts. Okay, you all know about AI. Okay, you are all without a day will passing out without hearing the term AI, ML, even deep learning, chat GPTs, all these things are intelligence, artificial intelligence. Okay, it's actually simulation of human intelligence in machines designed to think, learn, and solve many real world problems. So actually, ML is a subset of AI. Okay, I can say if you already know ML, DL, that the hierarchy is like this. A superset will be AI. Okay, under that machine learning comes. Then under that deep learning comes. You might have heard these terms. So the hierarchy of the pattern is like this. So ML is actually a subset of AI developing algorithms. Okay, that allow machines to learn from data and take decision without explicitly programmed or without human intervention. Okay, that is basically, if you think about ML definitions, you can understand these kinds of things. So what are the different types of ML techniques or ML algorithms? Basically speaking, there are three categories. Okay, so supervised learning, unsupervised learning, and reinforcement learning. I think you might or any idea? Have you heard these terms? Okay, so what could be supervised learning? So basically ML model work on data. Okay. I didn't get. Then what about unsupervised? Still? Self-aware. Okay. Yeah, somewhat okay, but learning we can do in three ways. That is these three ways. Okay. Supervised learning, unsupervised learning, reinforcement learning. So supervised learning means, as you all know, ML will work on data. Okay, so the data, suppose what kind of data? Say for example, if I want to, I will explain one kind of scenario. In a bank organization, one person is applying for some credit card. Okay, credit card. So bank has to take decision whether it has to issue the credit card for that person or not. Okay, so the bank will not take decision blindly. Okay, it will analyze the person and what is his profile, how much bank balance, what are his transaction histories, then what is its CIBIL score. That is one particular very important, I can say, feature, okay, or attribute of that particular person. And depends upon these kinds of data only, bank take the decision whether that person is I can say secure or non-secure. We can issue the credit card or not. Okay. So what the bank person is deciding here is whether that person is secure or unsecure. Okay. If he is secure, that the bank has some trust on him, so that he will repay the amount, credit amount he will repay. So if that trust is there, how bank will build the trust? From his features, from his attributes. What are the attributes? Not his appearance or anything. His transaction history, what is the bank balance? What are the score depends upon that. Okay, if he has some loan, what is the pattern of his repayment? Every month he's repaying his CMI value or not. Likewise. So depends upon that, the bank will take the decision. How the bank will take the decision? The bank cannot go to all the customers. Okay, so it has its own the customer data. Okay, so if the bank can build a model on those customer data, when a new customer comes, just give this customer's features to this model and make this model to predict that whether this person is secure or non-secure. That's completely an ML model. Okay, so what is happened here? The bank has past historical data. Say for example, bank has 1 lakh customers in their credit, okay, in their account. So these 1 lakh, all these 1 lakh customer data are there. And these customers, depends upon these, they have given some I can say some feature like this person, these many persons are secure, these many other persons are non-secure. Okay, this secure, non-secure, that is called label. Okay, so the data is labeled. If we are approaching this data with the learning models, this kinds of learning is called supervised learning because the customers are labeled. Okay, so all the customers are grouped into two, secure or non-secure. Okay, already it is grouped and given the label. So if the data has such kind of label, then it is called supervised learning. But we cannot expect the same thing in every real-time applications. There are cases, there are real-world examples, there are use cases. The data doesn't have any labels. The data will be there. It's actually a tedious effort process, time-consuming process. If one by one, every customer comes, the bank has to identify and give the label. It takes much time. But if the data is available, such data is available, it's good, it's great. We can apply supervised learning. If such kind of things are not there, label is not there, bank doesn't know these from these 1 lakh people who are secure, who are non-secure, then we can apply unsupervised learning. Unsupervised learning means the data will not have any labels, such kind of labels. So what model does this? There are different algorithms are there. Those algorithms will find out some similarities in these customers and group it into 1 or 2 or 3. Okay, so that one group will be, when we manually analyze it, one group will be having some similar pattern, like they are repaying the loan very periodically, regularly. They are maintaining their balance in very well manner. So those people, then we can give the label as what? Secure. Otherwise, other group is non-secure. Okay, so when such kind of data is not available, label is not available, we apply unsupervised learning. Still, third technique is reinforcement learning. What it could be? Any idea? Mostly reinforcement learning is not popular in this cyber or cloud security context. Reinforcement learning mostly apply in games development and all, because it's actually there will be an agent like a small software that works according to the response of the environment. Response of the environment will be the two players playing, what different players movement, and depends upon the movement. If the movement is favor or non-favor, it will give some reward. Depends upon the reward, it takes the next movement. It takes a decision for the next movement likewise. So basically what I am trying to say is these first two we can apply to the security part. Okay. So when you search what are the different models it is applying in cloud security aspects, there are some very well popular, very successfully implemented models. Support vector machine, extreme gradient boosting, means gradient boosting algorithms, random forest, KNN. These are all some of the sample supervised learning algorithms they have successfully implemented in detecting these attacks or this kind of intrusion kind of things. Okay. So these are basically built on labeled data. Okay. And making them particularly useful for threat detection. So these are some, what I am trying to convey is these are some of the supervised learning materials or sorry, algorithms. They are successfully implemented in different scenarios of threats. Okay. So how this algorithm works, what are the techniques of that, what are the steps? I'm not going into that particular details. If you are interested, you can go in that. Just note it down those algorithms, but still we will see simple code. Okay, the theory behind it, it's not the scope of this particular session. So still we can use unsupervised learning technique, particularly in anomaly detection. Okay, unsupervised learning technique, particularly very successful in critical cloud security aspects of anomaly detection, because it may not have label data. When in the scenarios, when the data is, when the label data is absent, we can go for unsupervised learning. Other very popular technique is natural language processing. Okay, it is another technique. See, if I say about machine learning models, what are the different applications we can apply in image kind of analysis, we can apply in text kind of analysis, we can apply in audio analysis, video analysis, different scenarios we can apply ML models. In that, language processing techniques. Okay, this has got different its own specific ML models. These ML models, it's very successfully implemented in threat detection. That is analyzing the security logs. Okay, so NLP has effectively utilized in system logs. Okay, the log timing, the login time, logout time, and if you collect such kind of data along with the other kind of features, whether that particular person is logged in some weird time or not, such kind of things, because it's a sequence kind of data, 1 week data or past 1 month data we can collect and apply some these kinds of NLP algorithms. Okay. So these are some of the, I'm giving you some ideas about what are the different ML models is successfully implemented in security aspects. Then we will see a simple code, then you will get more idea on that. So before going into that, again, what are the challenges in applying AI models? There are more benefits, but still data quality, model bias, explainability, integration. In the sense, an organization should ensure that, see, I said learning always happens based on the data. Okay, so the data should be quality one. What do you mean by quality data? Suppose what I said earlier is a small example of bank data, secure customer, non-secure customer. There were two classes. Okay, so in that two classes, the data should, we say that it should be properly balanced, in the sense each group should have somewhat equal amount of data. Then only we can build a good performing model. Otherwise, what happens now? Model can bias. Bias in the sense, if one particular group has more number of data than the other, while we build the model, it can have some bias towards that particular the high class. Okay, so that biasing should not happen. Okay, so the correct representative samples should be there for each of the classes. And explainability, because ML models are more complex. Okay, so now explainable AI, you might have heard about this term, explainable AI. What do you mean by that? See, we create different ML DL models on the data, but actually it works as a black box. Okay, so how actually what is happening behind? There are so many statistics and mathematical computations are working behind. Then only predicting some output. Okay, so how it is happening? So that is on, say for example, if I take the same bank customer data, on which feature the bank has taken the decision about this person is secure or another person is non-secure, whether is uh, last bank balance, or whether his CIBIL score, or whether his revenue, or what is his salary. Okay, on which particular feature, on what particular combination of feature bank has taken the decision, or ML model has taken the decision that this particular customer is secure, or this another customer is non-secure. Okay, there it is coming the role of explainable AI. Explainable AI will find out on which feature, okay, the ML has taken the decision. Okay, now another important challenge is integration. So integration of this AI ML to the cloud, that is very much cumbersome and more in terms of complexity and difficulty. So well-planned roadmap should be there to implement by the organization. So these are the different challenges. So data quality, we should mitigate the biasing. We should have to adopt some explainability component. Okay, so these are some of the real-time tools that is available in Cloud Secure, Google Chronicle, Microsoft Azure Security Center, AWS Guard Duty. These are all some of the real-time different Microsoft AWS and Google has adopted this AI tools to ensure the cloud security. Okay. Now, what are the future directions? So, future directions, if I think about that, there are many more and more techniques, more and more algorithms are coming up in AI field. Okay, but still, these are the future scope, I think. Quantum ML. Okay, quantum machine learning. So quantum machine learning has adopted quantum computing to finding out the more secure or more performing predictions. Okay, federated AI. Have you heard about maybe federated learning? Okay, so how federated learning work on AI models, so that multiple entities can train the model on decentralized data. Okay, then they can share the model parameters on the centralized server, and there the global model can be built. Okay, that is a federated AI concept. Then explainable AI, what I told just now. Edge AI, edge computing, without deploying into the cloud cloud server itself, we can adopt small AI models into edge devices like mobile, IoTs. Okay, there it will work, edge AI. Then ethical. Okay, ethical AI. So it can ensure, that means what I told. So the data should not be biased. Okay, should not be biased, should be fair enough, and it should be balanced. Okay, so ethical AI in security. So in responsible AI, ethical AI, there are lots of researches are going on. So these are the future directions, what I can say in AI while applying to the security aspects. Okay. As a conclusion, we will go on to the implementation part. As a conclusion, I can say that AI ML technologies undoubtedly improve the intelligence, adaptability, and proactiveness of the cloud security environment. These technologies will empower organization to improve the threat detection, prevention, and response. So, what I can say is many ML models are there, many DL models are there, but we should consider these techniques now. Most promptly XAI or explainable AI. Okay. And ethical AI. Okay. It should be bias free. It should be fair, and it should be well balanced data. So I hope the data set has been shared with you. This is what's a simple application I am just showing you. This is DDoS attack detection model. You know what is DDoS? Denial of service. Okay. Denial of service attack detection model. How we can build a model on. Here I am adopting 2-3 ML models. Okay. We are implementing on those data and comparing the performance. Which model will be better? Okay. So please download. So I am using here CIC IDS 2017 dataset. It is available in Kaggle. Kaggle you might be knowing. Okay, Kaggle is one platform where many kinds of datasets, publicly available datasets are there. Intrusion detection system 2017 dataset. It's a Canadian universities. They are maintaining this intrusion detection system dataset. Actually, it consists of it's a, I think 2 lakh datas are there of every days. Okay, Monday to Friday, I think Monday to Friday, all the transaction, what happened in that network. So login details, everything's are there. So from that, I took a sample of data. Okay, there are more than 2 lakh datas are there. There I have taken 2000 data so that it will be easy for you to implement some model. So if you downloaded it, please open your we can implement it on Google Colab. Okay, please open your Google Colab. Google Colab you can open. And that dataset is shared. You can upload it in your drive or in your local system also. Either way, you can access the data from your drive or from local drive. Please open Google Colab and new page. Okay. If you open Google Colab, new page you can take new Colab page. New Colab page. Everyone has done? Done? New page. Okay. Yeah. I hope everyone has some experience in using Colab. Okay. So there, please upload your dataset file. Friday working hours sample. This dataset I already uploaded there. You can click on that left pane, files. If you don't know how to upload the file, I will say the procedure. In the left side pane, you can see one file icon over there, files. Click on that file. Then you can click on this upload to. Okay. So first you upload to your drive or local machine. Just click on this left side files icon, this one, files, so that you can see 3-4 options over there. This is uploading to session storage. When you click on this session, it will open the file sessions corresponding where the file has been you saved. From there, you can select and open it. Otherwise, you can mount the drive, Okay, mount drive option. This mount drive option, if you click, your drive will open it. And from that drive, you can select this particular file. Done? Done? What about here? Take a new page, new file, new notebook. That data set downloaded here in the system. Okay. Yeah. Just click this file. Just let it be connecting. It is connecting only. You can see over there connecting. Just wait. Yeah. Now you can, yeah, the here. Click on that arrow where it has been, yeah, open. Okay, yeah. Same way. Okay, just help him. Done? Any doubt? Done. Both of you. Done. I hope the people in online also has done that. Okay, this is done. Okay, so first of all, let us see what is the data like. Okay, this is actually a CSV file. Okay, what I told 2000 samples I had taken. So here is the data. When you scroll it, it's an Excel CSV file. When you scroll it, you can see different rows and columns. If you are not familiar with the CSV files, I will say you. This rows indicate the data. Okay, the rows indicate data. Likewise, I have 2000 data are there. 2000 data. And the column indicates features. Okay, so the data, what I told, for ML models to build, the data should have features. Okay, so these columns are called features. Okay, so this particular data is extracted on a particular day, Friday. What happened in that network? Okay, what happened in that network? So you can see the destination network, in the sense the packets has thrown, and what are the packets it's coming back, some network data. Okay, so if you closely look into the column, you can see destination, flow duration, total forward packets, total backward packets, total length of forward packets, total length of backward packets. So forward packet length maximum. So likewise, there are around 80 features are there. Okay, if you scroll to the right side, you can see over there are 80 columns. That means there has been 80 features of that particular network has extracted. Okay, in data or information has been extracted. Now, last column you can see label. Okay, if you look at the data, last column is label. So the last label, it is written as benign. And if you scroll down, all the columns are, all the rows, it is written as benign. Then it is coming DDoS. Okay, so DDoS. So that means there are two labels. There are two groups or two classes over here. One is benign transaction happened. Okay, benign transaction happened. And another is attack happened. Okay, DDoS means denial of service. So by collecting this data, we have got two kinds of data. One is benign and another is attacked data. Okay, so on this networking, so there are two classes, benign happened and attack happened. So this is actually collected from the network, and this data we are making use for our building a model. Okay, so we need such kind of either a labeled data or some unlabeled data to build the ML models. Now just go back here. We are going to work on this. Okay, so do you have some basic idea in Python? Okay, that's fine. So first you have to import pandas and import numpy. Please do that. I think there is no more explanation needed. Pandas are libraries. Pandas and numpy are very useful libraries in Python for handling the CSV files. And for different computation, we use numpy. Is it visible? I'll make it zoom it. So first, two lines of code you have to do is import pandas as PD and import numpy as NP. Okay, so this is what kind of data? Labeled or unlabeled? Labeled data. Okay, there are two classes, benign and DDoS, denial of service data. Okay, so here we are applying a supervised learning technique. 2-3 algorithms we can implement. This done? Okay. Huh? Done? Okay. All of you? And just if you are not familiar with the Colab, you can click on this left arrow, then it will run. Okay. So we have imported two useful libraries to handle this data, pandas and numpy. Now next one is, so you have uploaded the sample data in your Colab resource, Colab server. Now you have to import that to your read the data. Okay, for that the code is pd.read CSV. In that bracket, you have to give the path for that data. So in this data, you can just right click, copy path. Okay, just right click on that data set, copy path, and between this bracket, you can just paste it. Okay, pd.read CSV, one bracket. Inside that bracket, you can paste the path. Okay, pd.read CSV is the code for reading the data set, CSV file. So that what you have done now, you have read the CSV file into a pandas data frame. Okay, so now it will act as a table, rows and columns format. So that read data, we have saved it in a variable df. I have given one name, variable name df. df is equal to pd dot read csv. Inside the parenthesis, you can paste the path. Fine. Done? Okay. Now your data is read now. So how many data are there? How many columns are there? We don't know any idea. So for that I'm just trying df.shape. df.shape is the code for finding out the dimension of the data. How many rows are there? How many columns are there? Okay, you can just give df.shape. Done? So after seeing the dimension, you can do next as df.head. So that means dot head will give you the first 5 rows so that you will be able to see what are the different features over there. Destination port, flow duration, total forward packet, total backward packet, likewise up to the label. Okay. Fine. Here, what about you doing? Okay. Now, after seeing the sample first 5 data row, we are moving on to this part. Actually, what happened now? This many columns has many infinite kind of data. Infinite means very large numerical data values were there. If you look at this data CSV file, there were many. When you going down, there were many infinite values. It's some error was happening. So what I done is we have to clean the data. Okay, so what I am doing is one particular command for cleaning the data frame data is df.dropNA. So dropNA is actually dropping the null values. Okay, but we don't have any null values over there, but there were many infinite and minus infinite values. So what I done is df.replace np.inf means np.infinite and minus np.infinite. I replaced with the np.nan, nan, not applicable values or null values. I replaced those infinite values with the null values. Then I dropped that null values. So drop in a basically what did is, so if suppose once some cells will be having some null values. So those corresponding rows and columns that will be dropped, deleted. Okay, so what we are doing here, many infinite values were there, which is very difficult to handle. So that infinite values we replaced with the null values. Then those null values I drop. Then indexing I am resetting. Rows and columns are deleting. So we have to reset the index. that parentheses are very important. Carefully do the parenthesis part. Square bracket and that rounded bracket. Is it visible, right? If you have any doubt, please ask me. Online. Doubts are there. Where is it? I should ask them. If you have any doubt, please, online participants, you can ask me. Fine, up to here. Okay, what we have done, we have imported some libraries. We read the CSV file. Okay, then what we just observed, how many rows and columns are there. Then some cleaning part I am doing. Okay, this is the cleaning part. Some infinite values were there. Those corresponding values I am dropping. Okay, now see, when you look at this data, all the values are numerical, but except the last one, except the last column, label, that is benign, and it's a string value, character value, that we have to convert it into numerical form. That is what next what we are doing is that label column benign to 0 and DDoS to 1. So we have now two classes. Okay, benign 0 and DDoS 1. So converting the label is into the corresponding 0 and 1. Because in order to feed to the model, we need all the numerical values. Again, be careful about the brackets. This may raise errors. Okay. It should be correctly closed. The chords also. Done? All of you done? Okay. Let me move to next session. Next section of code. Import drive, that is not needed. Now I am just trying to plot my data set. Okay. What is whether the data is balanced or not? I must see. Okay. So what I am doing is this code just skip for time being. I will share this code. Then that time you can just practice it. Okay. This I am just trying to plot it. What is my distribution of my data set? So that is just I am seeing over here. So I'm just plotting this so that you can see over there. Benign class 0, not moving properly. Yeah, benign class 0 and the DDoS class 1 both have equal amount of data. Okay, 1000, because it is showing over there the 1000. Both the vertical bars are 1000. It is indicating 1000. Y-axis is count. Okay, please skip this particular code for now. I will share this, then you can, because it's more lines of codes are there that takes some time. So now I saw that my data is balanced. Okay, both the group has almost equal number of data. If that is not the case, there are many measures to make it balance. How to handle, address the data imbalance problem. There are different techniques are there. So we have to take that also. But for this particular data, it is now balanced. Now what we are going to do? So almost all the pre-processing part over. These many things are called pre-processing. Data pre-processing. Before we are feeding into the model, we have to do some pre-processing things. That means any cleaning part we have to do. Some string columns features are there. You have to convert it into numerical forms. So likewise, there are so many things. So that is called pre-processing. That is over. Now what I am doing here is, now it is ready to give to model. Okay. So what I am doing here is, first, actually what we are doing, the data has two classes, benign and DDoS, right? So when a new packet's information comes, if I feed this packet information to my model, it should predict us whether that was benign or DDoS. Okay, that was an attack or that was a benign. Okay, so that is my aim. For that, a model will be having, normally machine learning models is not like traditional programming concepts. Okay. So traditionally what we do in programming, we will have some algorithm. We will give the data to that. Algorithm will process, compute on the data, give the output. Right. Suppose say for searching, sorting, finding some percentage or Fibonacci series, many things you can do like that. But in machine learning, what is the difference is, you have the data, you have the output. Okay. On this input data and output, you are building a model. You are building an algorithm. That is basically what is happening. What is here input and output? Input is all the features. Output is your, if you consider this data sample, output is your label. Okay. All the columns, there are almost 80 columns. Okay. So the last column is your label. That is the output. All other 79 columns are your input. That is features. Okay. All these features you are feeding into the model and the output will be your label. So while learning, the machine will map these every features to corresponding output and find and learning that, oh, this, when this particular feature comes, it should map to this particular output like benign. When these particular features are there, it is it's to be read as DDoS. Okay, that is what actually happening when the learning process. Okay, so using some mathematical computation process, the machine will map all these features to corresponding labels. Okay, understood that? So what here we are doing is, our features will be the input and the label will be our output. Normally in ML, we represent it as two variables, X and Y. Okay, X is our input features. All the 79 features are our X. Y will be what? Our labels. Okay, Y will be label 0 and 1. X will be all the 79 features. That means how many rows? 2000 rows. So X dimension will be 2000 into 79. Okay, Y dimension will be what? 2000 into 1. 1 is all the label values. That is, it's a column matrix. It will be column matrix. The X will be our two-dimensional matrix. 2000 into 79. So what I am doing here is, from my data frame, I am extracting X and Y. So for that, I can take this X is equal to, let me set aside from that particular code. I will explain it. So what I am doing here is X equal to df dot drop label comma axis 1. That means from the data frame, I dropped my label, and rest of the columns I am taking and saving it into the variable X. Okay, that is the meaning. df dot drop label axis 1. That is, I am saving it into the variable X. Y is df of label. Understood. So please do this both the lines. X is equal to df dot drop, in bracket you can write label comma axis 1, y equal to df of label. Okay, X is now what? Feature. This is called feature vector. Okay, X is called feature vector. So this feature vector is what we are feeding into the models. Output is our Y. The dimension should match. If X is 2000 is first dimension, Y also should be 2000. Understood the concept? Okay. X is called feature vector. Y is the output. Here it is label. So Y will be having 2000 data with values of 0 and 1. X is having 2000 data with values of different those feature values. 2000 into 79. That is our matrix X. Y will be 2000 into 1. So X is now in the form of a two-dimensional matrix. So when you feed to the ML model, say for example, some model like neural network or support vector machine or decision tree or random forest, there many computation happens. Okay, this computation will happening over this matrix. Okay, many kinds of dot products it will happen, and it will find out and then map to the output Y. Okay, it will map to the output Y. So find X and Y over. So now what happened? My data, I extracted my feature and I saved it in X variable, and the output I saved it in Y. Now I am going to feed to the model. So what is actually learning? So learning as I said earlier, each feature value, if I take one feature, it's a full one row. This row value will have to map to the corresponding output value. It could be 0 or 1. Okay, it could be 0 or 1. So what is happening here is that mapping is called training. Okay, we are training our model. That means we are making our model to learn from the data. Okay, that means, training. Training means if what we are learning, seeing some things. Suppose I am seeing this laptop, I understood because I have seen many times this. That is why. Okay, so the data, we have to train our model. Then after training, we should check whether the model has learned well or not. There what we do testing. Okay, so in learning, there are two phases, training and testing. So for that, how do we do this training and testing? Using the data. Okay, so for that, I divide the data into training and testing. Training group and testing group. So there is one import library is there, train test split from sklearn.model underscore selection, import train test split. Then what I do is using this train test split function, I can divide my X and Y into two parts, train and test. What I am doing is X, I have to divide it into train and test. Y, I have to divide it into train and test. Okay, so that is what I'm dividing X and Y into four variables. What are they? X train, X test, Y train, Y test. Okay, X train and Y train I will use for training purpose. X test and Y test I will use for testing. Got it? So this is the code for that. Train test split in the bracket. So before that, you have to do this particular, write this code from sklearn.model selection, import train test split. So Python has many beautiful such kind of libraries. Otherwise, what we should do? I have 2000 data. Okay, so I have to manually select some, say for example, 80% data and some other 20% I have to set aside. It is very difficult. So I can divide using train test split function. So now just see what are the parameters inside this train test split. You can see over there, X parameters are X I am giving, Y I am giving, test size is 0.30. What do you mean by that? So I told we are dividing the data into train and test, two groups. Okay. How many I should reserve for testing? Some amount I should give. So what I am doing here is 30% I am making us test data. Other 70% I am taking for training. Okay. So X train and Y train, automatically the machine will split. Okay, this function, train test split function will divide the data into 70 and 30. 70% data will go to X train and Y train. 30% will go to X test and Y test. Okay. Then I am just trying to print it so that train data set size is 1400, 79. Test data set is 600. So the dimension should be, number of columns should be correct. Okay. So out of 2000, 1400 are training. So I am giving two model for learning. From this 1400 data, machine will learn. And if the machine has learned or not, I am testing using 600 data. Okay. So how I am testing? That is the next question. So the machine learned from 1400. Every time, whenever new row it is taking, it is mapping to the output label. And then after the training happened, this 600 data it will take. 600 will be in now X test. Okay. So after training with this 1400, the idea is this. Please listen. With the 1400 data, I build my model. I train my model. Okay. Then I have 600 data with me. I will just give this 600 data to the model and make this model to predict. Okay. To predict the label. For the 600 data, my model now will predict 0 or 1. If it is predicting 0, that means it is a benign. If it is predicting 1, that means it is a attack, a denial of service. Okay. Now, whether it is true or not, the predicted value is, it is true or not. How do we find out? So its ground truth value, actual value is there is in Y test. After prediction, I will get the values. I will store it in y predict. Okay, I will save it in y predict. Then I will compare my y predict and y test. How many has got correct prediction? Okay, suppose 600 are there. Suppose first 10 you take. First 5 belong to 0. Next 5 belongs to 1. Okay, so after prediction, 10 I got. Y prediction 10 values I got. In that, out of first 5, 3 got same 0. Then last 5, again 3 got same 1. So how many true things happened? 3 plus 3, 6. 6 data correctly predicted. 4 data got wrong. Okay, 6 is called true positive. Okay, true positive. That means it is truly predicted. Machine predicted it is true. But 4 got missed. Somehow, machine has not learned properly, or some way it has got some wrong answer. Instead of 0, it got 1. Instead of other 2, 1, it got 0. So 4 misclassed. So what is the model performance? Out of 10, 6 got correctly predicted. So 6 by 10. That means how much is the percentage? 60%. 0.6 or 60%. That means I can say that my model is working 60% good. Okay. So this is the way we will train the model. We will test the model and finding out whether my model is performing on what basis, or what is its performance status. Okay, how I can quantify my model performance. Okay, so that particular 60% is called accuracy. What is called accuracy? How much my model is accurate? That means 60% my model is accurate. 60% my model is accurate. So accuracy is one measure for one metric for measuring the model's performance. Any machine learning model's performance. Accuracy. There are other different metrics are there. One is precise. How much precise my model is. It is very much different from accuracy. Another is recall. Then another is F1 score. So there are these kinds of metrics to measure the model performance. That means from accuracy, I got that model performed 40% well. Sorry, 60% well. For each of the class, how it performed. For the benign class, how many got true, how many got missed. For the DDoS class, how many got true, how many got missed. So for such kind of class-wise comparison, I can use precision, recall, then other kind of things like F1 score. Okay, so class-wise, how the model is performing. There I can use metrics like precision, recall, F1 score, such kind of things. Okay, so this is the overall idea about ML models, training, testing, and measuring the performance. Some idea you got, right? Now I will explain the code because not much time to type and run the code. I will share it. So here so far you have splitted it into train and test. Now I have 4 variables: x train, x test, y train, y test. Okay. So 1400 data for training, 600 data for testing. First machine learning model I am implementing is random forest. Okay, just I am giving the random forest. I am importing the random forest library. And what I am building here is, I am calling one model, random forest model, rf model.fit, x train, y train. This particular code is actually the code for training the model, .fit. Okay, So random forest classifier is the corresponding library in scikit-learn. Okay, for building the random forest classifier or algorithm. There, I am calling that particular library function and saving it as a RF model, and with the RF model dot fit. Fit means training the model. There I am. What are the values I am passing to that model? X train and Y train. Okay, X train and X feature vector and the corresponding output Y. Okay, then after fitting, what will happen? The model has now learned. RF model is ready. Okay, now I am trying to predict the RF model for X test values. 600 I have set aside for testing purpose. That X test parameter I am passing to the RF model for prediction. So RF model dot predict X test. That prediction value, predicted 600 Y values will be saved in RF predict variable. Now I have got 400 predicted values. Getting the idea? Are you following me? Okay, so just have it in your mind, all this process we have trained. Now we are giving the model for prediction. That predicted by, how it is predicting? By providing test values. It is predicted. That predicted value is there in RF underscore predict variable. Now I have to measure my model, whether the random forest is good or not. How I will measure it? My actual value is there. In which variable? Y test. Y test and predicted value in RF predict. Okay, that I am comparing. So for that we have different libraries: accuracy score, FN score, precision score, recall score. These all libraries are available in scikit-learn. There you can import. And what I am doing here is accuracy score. I am calling the function accuracy score by providing two parameters: Y test and RF predict. This is the actual value. Okay, Y test is having actual value. RF predict is the predicted value. Both the values I am giving. Then the accuracy score function will compare those and finding out. Suppose what I told earlier, out of 10, 6 got accurate, 4 got missed. That particular computation will happening over there and finding out that accuracy is 1. Likewise, FN score, precision score, recall score. Precision, recall, FN score are different metrics. Just I am introducing the terms. It has lots of things to explain. If you are interested, you can just Google it. Okay, what is precision, recall, and FN score? But have it in mind. This is 2-3 metric for measuring the model's performance. Okay. So here all the values I am getting as 1, 1, 1. That is means random forest is perfectly well in this particular data set. 100%. That is a meaning. I am just trying another model also. Another model is called logistic regression. There also, you got the flow of the training part. Just see over there, I am importing my library, logistic regression. Okay, I have made a model, LR model, logistic regression model. I am calling my model dot fit. What is fit? Training. Okay, dot fit means training. Training with what? What are the values? X train and Y train. For training, you have to supply X variable and Y variable. Okay, that is X train and Y training. I am applying and fitting my model. Fitting means training my model. Then after training, I am what is the next? Prediction. Okay, predicting with the test data, X test. Now my predicted values are there. Again, what I can do? I can compare my true value with the predicted value. There I am doing this accuracy score, Y test, comma, LR predict. LR predict is the value that is predicted from the logistic regression model. Then now I am getting the accuracy as 0.98. That means 98% it is accurate. Who is accurate? Logistic regression model is accurate. So likewise, I am trying neural network, another supervised learning thing. There, what I am doing, I am calling MLP classifier. MLP means multi-layer perceptron. Neural network name is called multi-layer perceptron. Okay, that means neural network has different layers. Okay, so I am just calling that function. My model I defined NN model, neural network model. Again NN model dot fit. But I am doing training with my train and X train and Y train. Then same process I am predicting. My predicted value is there in the predicted variable. Then I am comparing Y test and NN predict. Y test is the actual value. NN predict is the predicted from the neural network. Then I am getting the accuracy as 0.78. That is 78%. So, which is a good model over here? First one, random forest. Okay, random forest is the good one because it is got 100% accurate. So, if you give a new data, if I get a new data, I can give to this model and we can find out whether it is benign or denial of attack, denial of service. This is what altogether I plan to give you. So this code I will share with you. Then if you get any doubt,
Online participants, if you have any doubts, please feel free to ask. You can unmute yourself or you can come up in the chat box.
so I will share the PPT. There I quoted some use cases in cloud security part. Where are all these machine learning models we can apply? So if you are interested, you can explore those use cases. Okay. And what are the data set available in those use cases? Mostly Kaggle is a portal or place you can see many kind of data set. You can see malware detection data set, this denial of service data set. Likewise, many such data sets are available. As a starting point, just take some sample of data, apply different machine learning algorithms. Small codes are available. Just experiment on that. Okay.
Thank you, ma'am. On behalf of the organizing team and all participants, I extend heartfelt thanks, dear ma'am. Your insightful and highly engaging session today, your detailed explanations and hands-on guidance during the implementation session have been especially valuable, offering practical clarity alongside the theoretical concepts. We truly appreciate the effort and dedication you brought to make the session both informative and interactive. Thank you, ma'am.
Thank you very much.
So as we approach the end of day 2 of our 1-week faculty development program on secure cloud, AI, and distributed system, I'd like to thank every participant's enthusiastic engagement and active participation throughout the day. We look forward to welcoming you all tomorrow for another day of learning and collaboration. Until then, have a wonderful evening. Take care. Thank you.